Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on gravitational field from March 2022, Paper 4, Variant 2. In this question, we will discuss how to calculate mass of a planet. We will also discuss how to sketch gravitational field around any mass. At the end of this lesson, we will also discuss how to calculate orbital speed of Moon. For question number 1, part A, it is given to us the point P in figure 1.1 represents a point mass. On figure 1.1, we need to draw lines to represent the gravitational field around P. This dot P is representing point mass. In order to draw lines around point mass, we need to understand gravitational force is an attractive force. So the lines has to be pointing towards this point mass. So this is how you can draw the lines of gravitational field. So lines has to be pointing towards this point P. So this is how we can draw the lines. You have to draw at least 4 lines, but you can draw more than 4 as well. So we can draw 8 lines. So this is how we can draw the gravitational field around the unit mass. Now the question is that why these lines are pointing towards unit mass. One reason you can say gravitational force is always attractive. The second way to explain this one is if we place a unit mass, let's say at this point. So this one is over unit mass and this is the point mass. So the force on this unit mass, it is towards point mass, means it will experience attractive force. If we place unit mass here, this will also experience attractive force, means direction of force on this unit mass is towards the point mass, So that's the reason we have to draw arrows pointing towards point mass. Or simply you can say gravitational force is always attractive force. That's the reason these arrows are directed towards point mass. This question has 2 marks. If you have drawn the 4 lines and they are pointing towards point mass, you will get 2 marks. For part B, it is given to us a moon is in circular orbit around a planet. Explain why the path of the moon is circular. First, imagine that we have a circular orbit and at the center of this circular orbit, planet is located. So the planet is located at the center of this orbit. Then the moon is orbiting around this planet. So we can use letter capital M for the moon. Imagine that the moon is moving in counterclockwise direction. So we need to understand as the moon is moving in a circle, so there must be a centripetal force because this one is doing circular motion, so there must be a centripetal force. Now we need to understand centripetal force is not a force by itself. So centripetal force has to be provided by another force. Centripetal force in this case is provided by gravitational force. So we can simply write down in this case centripetal force is provided by gravitational force, means force on this moon by the planet. So this one is the gravitational force. So this is our 1 point we can write down. Now we need to understand as this moon is moving in a circle, in a perfect circle, so the angle between this force and velocity of the moon, it has to be 90 degrees. So we can say the angle between gravitational force and the velocity of the moon is 90 degrees. Or simply we can say the centripetal force is perpendicular to velocity, or we can say gravitational force is perpendicular to velocity of the moon. So this can be the second point. And the third point we need to understand as this moon is moving in the circular orbit, means it is moving in a perfect circle. So the magnitude of gravitational force means the magnitude of centripetal force, it has to be constant. So we can say gravitational force acting on the moon is constant. So we can say gravitational force is constant. So these 3 points we have to write down for the answer of this question. Now let me show you how you can write down a proper answer. So this is how you can write down your answer. First thing, you can say gravitational force provides the centripetal force. You cannot say gravitational force is equal to centripetal force. Gravitational force provides the centripetal force. So you have to say provides, not equal to. But the centripetal force is perpendicular to velocity of the moon and magnitude of gravitational force is constant. So these 3 points you can mention. If you write down, you will get 2 marks. For part C1, we need to show that mass capital M of the planet is given by this expression. Means mass of the planet is equal to gradient over universal gravitational constant. First of all, let's imagine that mass of the moon, small m, is representing mass of the moon. So simply we can write down here, small m is representing mass of the moon. In this question, we have already discussed that gravitational force provides the centripetal force. So now we can say Fg, we can equate this one with Fc. Fg, gravitational force, this is equal to capital G, capital M, small m, means mass of the planet times mass of the moon divided by the distance between the centers of moon and planet. And this is equal to centripetal force, mr omega square. Now in this case, you can see we have m on both sides, so we can cancel this m with this m. So simply we can cancel mass of the moon on both sides. We have to show that capital M is equal to gradient over G. Now we can rearrange this one, so we can write down mass of the planet. This is equal to r cube times omega square divided by G. Now if you look at the gradient of this, so we can write down here gradient of this graph is equal to r cube divided by 1 over omega square. If we simplify this one, we can write down gradient is equal to r cube times omega square. So if we look at this expression, this is equal to gradient. So simply we can replace this one with gradient. That's all what question is asking us to find out. So we can say mass of the planet is equal to gradient divided by universal gravitational constant. So if we have done this one, you will get 2 marks. First mark you get, that is M mark, if you have written this expression. Means you have equated gravitational force and centripetal force. Means if you have written the formula for gravitational force and centripetal force. And the second mark is the answer mark. If you have got right answer, you will get the second mark. For the second part, we need to use figure 1.2 and the expression in C1 to show that mass capital M of the planet is 1.0 times 10 to 26 kgs. This is figure 1.2. So here we have figure 1.2. We have already found expression for mass of the planet, and we have found that mass of the planet is equal to gradient of figure 1.2 divided by capital G. Capital G is a constant, so we can find the value of capital G from given values of constants. So we don't need to worry about capital G because its value is given. What we need to find out is we need to figure out the gradient. So first of all, let's try to find out gradient. In order to find gradient of this line, we will take 2 points. So we will take 1 point here and we will take another point here. So this point is at origin. So in this case, simply we have value of r cube, that is 4.1. So we can say this is 4.1 minus 0 times 10 to 23. This is very important, this multiple. And if you look at value of 1 omega square, we have 6.6 0 minus 0, and this is also multiplied with 10 to 7. So this is value of gradient. As we can simplify, we can write down this is 4.1 times 10 to 23 divided by 6.0 times 10 to 7. Now we have to plug in this value for gradient. So simply we can say gradient is equal to 4.1 times 10 to 23 divided by 6.0 times 10 to 7. So this is value of gradient. And we have to multiply this one with 1 over g. So we can write down value of g here. G is equal to 6.67 times 10 to negative 11 Newton meter square per kilogram square. Now we need to solve this one. If we solve this, our final answer up to 2SF will be equal to 1.0 times 10 to 26 kgs. So this is our final answer. And this question has only 1 mark. If we have got the right answer, we will get this 1 mark. For the last part, we need to determine the speed of a moon in orbit. It simply means that we need to determine the orbital speed of the moon. So we can write down, we need to calculate orbital speed of the moon. Means in this case, we have planet that is at the center of the orbit, and we have the moon, and the mass of the moon is small m. We need to find out what is speed of the moon. We need to find out what is the speed of the moon in this orbit. So that V is called orbital speed. But orbital radius is given to us. Means the distance from the center of the planet to center of the moon is given. And this one is orbital radius. Let's say this is R. In order to answer this question, again we have to start from gravitational force provides the centripetal force. Again we have to write down gravitational force G capital M small m over R square, and this is equal to mv square. Now we will be using mv square because we need to find the speed of the moon. So we have to find speed of the moon, so we will use v instead of omega. Now in this case, again we can cancel mass of the moon, so we can cancel mass of the moon, and this 1 r we can cancel with this. So we left with G capital M over R, and this is equal to V square. So we can simplify this one. We can write down V is equal to G capital M over R root of this. G is a constant, and the value of G is 6.67 times 10 to negative 11. And mass of the planet we have just found in second part, that was equal to 1.0 times 10 to 26 kgs. And we need to divide this one by orbital radius. Orbital radius is 1.2 times 10 to 8 meters. And we need to take root of this. If you take root of this, we will get our final answer. Final answer will be equal to 7,500 meters per second up to 2SF, and this is our final answer. This question has 3 marks. You will get the first C mark if you have equated these two forces. You will get first C mark, and the second C mark you will get if you have plugged in values of capital G, capital M, and orbital radius. Then the last mark is the answer mark. If you have got the right answer, you will get the third mark. Our answer is up to 2SF because the least number of SF in given data we have is 2SF. That's the reason our final answer also has 2SF. Welcome to A-Level and AP Physics. In today's lesson, we will discuss one very important past paper question on thermodynamics from March 2022, paper 4, variant 2. I said this question is very important because in this lesson, we will discuss some key concepts about thermodynamics, and these key concepts are very important for your exam. For question number 2, it is given to us a fixed mass of an ideal gas has a volume V and a pressure P. The gas undergoes a a cycle of changes from x to y, y to z, and finally z to x, as shown in figure 2.1, as shown on this PV diagram. Question is asking us, for part A, we need to state the change in internal energy delta U for one complete cycle x, y, z, x. Means for the gas, if this is the complete cycle from x to y, then from y to z, and finally from z to x. If this is a complete cycle for a gas, we need to state what is the change in internal energy. Let's try to understand some key concepts about internal energy before we answer this question. So the first key concept you need to understand is delta U is equal to 0 if the initial and final state are the same. If initial and final state are the same. So simply we can say if initial and final states are the same. Initial and final states are the same for any ideal gas. In that case, delta U is equal to 0. Or simply we can say for any complete cycle, means if gas undergoes a cycle of changes. So we can say for any complete cycle, delta U is equal to 0. So very important point. Actually, this point you need to answer this question. And the second thing we need to understand is that we can also say delta U is independent of path. It doesn't matter if gas started from here, for example, from X, it goes this way, then go this way, then go this way, and finally come to this one. Still, delta U is equal to 0 if initial and final states are the same. So in this case, you can see this gas undergoes a cycle of changes. That's the reason delta U has to be equal to 0. And this is B mark. If you have written this one, you will get this 1 mark. For part B, question is asking us to calculate amount N of gas. Means question is simply asking us to calculate value of N. Means the number of moles. And we are talking about ideal gas in this case. For any ideal gas, PV is equal to nRT for any value of P, for any value of V, and for any value of T. So simply in this case, we need to calculate N, we need to calculate number of moles. So simply we can rearrange N is equal to PV over RT. For this ideal gas, value of P is given to us. So this is value of P. So simply we can plug in values now. We can say P is equal to 1.5 times 10 to 5, and we need to multiply this one with V, and the value of V is given to us, and this is equal to 4.2 times 10 to negative 3, and we need to divide by gas constant, and value of gas constant is 8.31 joules per mole per Kelvin. So we can plug in this value here, and finally temperature has to be in Kelvin. Temperature is already given in kelvins, so simply we can plug in value of temperature. So if we calculate this one, our final answer will be 0.14 moles up to 2 SF. So this is our final answer up to 2 SF. We have to use 2 SF in this case because the least number of SF we have is 2, and here also we have 2. So our answer has to be up to 2 SF. And this is our final answer. This question has only 2 marks. If you have used this formula, you will get 1 mark. And if you have got the right answer, you will also get a second mark. Means you will get 2 marks in total. So this is how we can answer this type of problems. For part C, we need to complete table 2.1. Means we have to enter the missing values of P and missing values of V in this table. So these missing values we have to enter. In order to answer this question, we need to understand 2 things. First thing, we need to understand how to use PV is equal to nRT, this ideal gas equation. And the second one, we need to understand how to read PV diagram. So this is the first thing you need to understand. The second one, you need to understand how to read PV diagram. If you look at X and Y, so the value of P at this point and value of P at this point is the same. So simply we can say the value of P for state X is the same as value of P for state Y. And that value is given here. That is equal to 1.5. So simply we can say this is equal to 1.5 times 10 to 5 Pascal. So here we can enter for y. This is also 1.5. So this is how you can find the value of p at y. Now let's try to find out value of v at y at state y. So simply we can say this is vy and we need to find out value of v at y. For that purpose we have to use this ideal gas equation. We can say in this case v is equal to nRT divided by p, and we have already calculated that was equal to 0.14 moles, and R is gas constant, so we can say this is 8.31 joules per mole per Kelvin, and temperature is in Kelvin. T has to be in Kelvin. It is already given, it is in Kelvin, so we can write down value of T. Now we need to divide by value of P, and the P at Y we have, that is 1.5 times 10 to 5. Now if we solve this one, our final answer will be 1.8 times 10 to negative 3 cubic meters, and that is the answer for V. So simply we will write down V is equal to 1.8 cubic meters. 1.8 times 10 to negative 3 cubic meters, because 10 to negative 3 is written here, so you no need to write down here. Now we need to find out value of V at Z. If you look at this one, from Y to Z there is no change in volume, so volume stays constant but P is increasing, so simply we can say Vy is equal to V3. We can read this one simply from diagram. So value of V at Z is also equal to 1.8 times 10 to negative 3, and that is the answer. This question has 2 marks. If you have got right value of the P, you will get 1 mark, and this is the mark. And if you have got these 2 values right, you will get the second P mark. So this is second P mark. For D, it is given to us the first law of thermodynamics for a system may be represented by the equation delta U is equal to Q plus W. We need to state with reference to the system what is meant by these symbols. First one is delta U. Delta U simply is the change in internal energy of the system. So we can say this is change in internal energy of the system. So this is how you can write this, change in internal energy of the system. So this is one thing you can write down. Even you can say increase in internal energy of the system. It can be positive or negative. Q. Next one is the Q. Q is heat supplied to the system. Better way to say this one is thermal energy supplied to the system. So this is how you can write down thermal energy supplied to the system. So you have to write down system here. Next one is W. W is the work done on the system. So W is work done on the system. Often we say work done on the gas. So gas is our system. Work done on the system. So this is what you need to write down for part 1. If you have written this for delta U, you will get 1 mark, and this is B 1 mark. And for Q, you will also get 1 B mark. And for W, this is also another B mark. If you have written these 3, you will get 3 B marks. For the second part, question is asking us to explain how the first law of thermodynamics applies to the change Z to X. Means from this state to this state, Z to X. Z to X. But if you look at Z and if you look at X, simply we can see that the volume is increasing from Z to X. So the gas is expanding. So this is expansion. We can also find out from this table, if you go from Z to X, so this is the value of P actually, but if you look at value of V, so you can see from Z to X, V is increasing. So we can write down V is increasing. So this is expansion process. If it is expansion, it means work is done by the system, or we can say work is done by gas, and work done by gas is taken as negative. So this is one thing we can get from this PV diagram. Now let's look at temperature now. If you go from Z to X, you can see the temperature is decreasing. So if temperature decrease, it means delta U is negative. negative, means the change in internal energy, this is negative. So this is negative. Because delta U, this is equal to 3 by 2 K times delta T. If the change in delta T is negative, it means delta U is negative. Now, if we write down the first law of thermodynamics, we can say Q plus W, this is equal to delta U. As the change in delta U, this change is negative, and W, this is also negative. But for the Q, it can be positive, it can be negative. It depends on the exact value of Q, means how much Q has been added. So it can be positive, means heat can be supplied to the system, or heat can be released from the system. It depends on the exact values of W and exact value of delta U. But we don't have the exact values of delta U, and also we don't have exact value of W. So we cannot say something about Q. So simply we can mention these 2 points. So we can say as volume increases, work is done by gas. As temperature decreases, it means internal energy decreases because the change in internal energy is negative. So you have to write on these 2 points. You will get 2 marks. But don't try to explain this one with the help of thermal energy, because that is not possible, because we don't have the exact values of W and we don't have the exact value of delta U. This is how you can write down your final answer. If you have mentioned these 2 points, you will get 2 marks. As volume increases, work is done by gas. So this will be 1 mark. You will get 1 B mark for this one. And the second B mark is if you have written temperature decreases, so internal energy decreases, you will get second B mark. Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on simple harmonic motion from March 2022, paper 4, variant 2. In this question, we will discuss some very important points about simple harmonic motion. And those concepts are very important to understand simple harmonic motion in depth. For this question, it is given to us a small wooden block cuboid of mass small m floats in water as shown in figure 3.1. The top surface of the block is horizontal and has area A. The density of the water is rho. For part A, we need to state the names of the 2 forces acting on the block when it is stationary. When the block is stationary, so simply we can understand block is in equilibrium. So simply we can say block is in equilibrium. When the block is in equilibrium, there are 2 forces acting on this block. One is weight of the block that is acting down. So simply we can write down weight of the block is acting down. The second force, as this is in the fluid, so there is an other force that is acting on this block, and that is upthrust. So there is upthrust acting on this block. If we draw the free body diagram for this one, so we can simply draw weight is acting down, so this is W, and upthrust is acting up, and these 2 forces, they are equal in magnitude but they are in opposite direction. So this one is upthrust. So these 2 forces are acting on this block as this block is stationary. So these 2 forces are equal in magnitude but opposite in direction. So simply we need to write the names of these 2 forces. So we can write down one force that is acting upwards, that is upthrust, and the second force that is acting downwards, that is weight. So we have to write down names of these 2 forces, and this question has only 1 mark. If you have written these 2 points, you will get 1 B mark. For part B, it is given to us the block is now displaced downwards as shown in figure 3.2, so that the surface of the water is higher up the block. It simply means that before block was inside water up to this point, means this block was inside water. But now we push this block downwards, and now this much block is inside water. So more part of the block is inside water. So it simply means that upthrust in this case will increase, because upthrust is equal to weight of fluid displaced. So we can say upthrust is equal to weight of fluid displaced. Now the block is displacing more fluid, weight of fluid displaced. Now block is displacing more fluid. As block is displacing more fluid, it means upthrust on the block will increase. So this is first piece of information we can get from this given information. Now let's move on to next. What question is asking us? Question is asking us to state and explain direction of the resultant force acting on the wooden block in this position. Means when the block is in new position, what is direction of resultant force? We have already discussed there are two forces acting on the block when the block is stationary. One was weight. So this is weight of the block. We can simply write down this is weight of block that is acting downwards. But weight of the block does not change, because weight of the block is depending on mass of the block and value of G. But upthrust is depending on weight of the fluid displaced. Now we displace more fluid, means the block is displacing more fluid, so upthrust in this case increases. Before, upthrust was equal to weight, but now in this case weight of the block does not change, but upthrust has increased. So it simply means that there is resultant force in direction of upthrust. So we can write down F net in this case is upwards. So first thing we have to write down, we need to state. So we can say resultant force is upwards. So this is the first thing we have to say. So we can say as upthrust increases, because weight of the fluid displaced increases, so the upthrust is greater than weight. So we can say as upthrust increases. So simply we can write down here as upthrust increases, and upthrust is greater than weight of the block. Now upthrust is greater than weight of the block, so F net is upwards. So F net is upwards. These points we have to write down to answer this question. And this question has only 1 mark. Let me show you how you can write down your answer. In your answer, you can say as upthrust increases, as upthrust increases and upthrust is greater than weight of the block, so resultant force is upwards. If you have written this one, you will get 1 mark, and that is B mark. For part C, it is given to us the block in B is now released so that it oscillates vertically. It simply means that first of all we push the block down from equilibrium, and then we remove the force. When we remove the force, block will start oscillating up and down vertically, and the resultant force acting on the block is given by this expression. F is equal to minus ag rho x. X is the vertical displacement of the block from equilibrium. For part 1, we need to explain why the oscillations of the block are simple harmonic. So first thing we need to understand, when we can say oscillations are simple harmonic motion, so we need to understand the basic condition for simple harmonic motion. So we can write down conditions. Any object, if it is oscillating and do simple harmonic motion, then it has to obey A is directly proportional to negative x. Mean acceleration has to be directly proportional to x, that A and x, they have to be in opposite direction. So we can write down here, first condition is that A has to be directly proportional to displacement. Mean acceleration has to be directly proportional to displacement. And the second condition is that A and x they have to be in opposite direction. So we can write down the second condition. Opposite directions means when A is positive, X has to be negative, and vice versa in opposite directions. But this is also true if you look at F is equal to ma, resultant force is equal to ma. If mass is constant, then F is also directly proportional to A. If mass is constant, F is directly proportional to A. In this case, mass of the block is constant, so we can also say that F, if it is directly proportional to X, and if direction of F and X is in opposite direction, mean directions of F and X, they are in opposite directions, mean when X is positive, F has to be negative, and when F is negative, X has to be positive. If these oscillations, they fulfill these conditions, then we can say these oscillations are simple harmonic. Now, if you look at given equation, F is equal to negative AG rho times X. In this case, these three quantities, they are constant. Area of the block is constant, cross-sectional area G is constant, and density of the fluid is constant. So one point we can say in this case, A, G, and rho are constant. Rho, this is density of the fluid. Rho are constants. As these are constants, rho and G are constant, then we can say F is directly proportional to negative X. And this is condition for simple harmonic motion. F is directly proportional to X, but F and X, they are in opposite directions. So F is directly proportional to X. If you write down this one, you will get 1 mark. In order to get second mark, we need to write down the second condition for simple harmonic motion, or simply we need to explain this minus sign. This minus sign simply tells us that F and X, they are in opposite directions. So we can say F and X are in opposite directions as indicated by negative sign. So we can write down as indicated by minus sign. That's all what we have to write down for this question. This question has 2 marks. You will get 1 B mark if you have written the first one. And the second one you will get if you have explained minus sign. For the second part, we need to show that angular frequency omega of oscillations is given by this expression. But for this question, F net is given to us. F net is equal to negative AG rho times X. This is F net. So let me write down here. This is F net. But F net is equal to MA. So we can replace F with MA. So MA is equal to negative AG rho X. From here we can find expression for A. So we can write down A is equal to negative AG rho divided by M. So divided by M times X. We also need to understand the general equation for simple harmonic motion. And general equation for simple harmonic motion is A is equal to negative omega square X. So this is general equation, or you can say the basic equation for simple harmonic motion. So we can write down this is general equation for simple harmonic motion. So any object which is doing simple harmonic motion has to obey this equation. So A has to be equal to negative omega square X. But now if we compare these two equations, we can get value of omega. So here, so in this case, we have negative omega square. By comparing these two, we can write down like this, omega square X. This is equal to negative AG rho divided by M times X. X is common on both sides. We can cancel this. Negative sign we can cancel with negative sign. So omega square in this case is equal to AG rho divided by M. We need omega. So we have to take square root on both sides. So this is our final answer, and this is what we need to show. So this is our final answer. This question has 2 marks. The first mark you will get if you have written this. If you have written A is equal to this, you will get first mark, and that is M mark. Means you have to write down this expression. So then you will get this mark. And the second mark is answer mark. Here is answer mark. But condition is that you can get A mark only if you get M mark. If you don't get M mark, let's say you got 0 here. If you got 0 here, you will also get 0 here. Answer mark also will be 0. So this is must mark. So you have to write down this expression first, and then you need to get omega. M is must. But if you got M mark, this answer is wrong, for example, then you will get M1 here and you will get A0 here. But if you got 0 mark here, you will also get 0 mark here, even this is right. So you have to be very clear with this expression. You have to write down first this one, then you have to write down this. For part D, it is given to us the block is now placed in a liquid with a greater density. The block is displaced and released so that it oscillates vertically. The variation with displacement x of the acceleration A of the block is measured for first half oscillation, as shown in figure 3.3. For part D1, we need to explain why the maximum negative displacement of the block is not equal to maximum positive displacement. The value of maximum negative displacement is equal to negative 0.02, and the value of maximum positive displacement, so we can find out from here, and this value is about 0.016. So in this case, maximum, this is amplitude, but simply you can write down negative maximum displacement. The magnitude of that is greater than positive maximum displacement, or simply we can say in this case negative 0.02. This one is greater. We are talking about magnitude. Negative simply tells us direction of displacement, and this one is greater than 0.016. We need to explain this why is like that. So the first thing you need to understand in this case is, as amplitude is decreasing, if you look at energy of oscillations, we can say the total energy of oscillations, that is equal to 1/2 ma square omega square. So this is total energy of oscillations. In this case, amplitude is decreasing. It simply means that energy of oscillations is decreasing. So we can say in this case, ET of oscillations decreases as amplitude is decreasing. So we can say energy of oscillations in this case is decreasing. Why it is decreasing? So we can say this is due to damping, because damping is involved. So energy of oscillations is decreasing due to damping, and damping is caused by, so we can say damping is caused by viscous forces, means forces due to fluid. So we can say due to viscous forces. That's all what we have to write down. Now let's try to write down the answer for this question. So simply we can say in this case energy of oscillations decreases. So we can write down energy of oscillations decreases. Energy of oscillations decreases due to damping. Energy of oscillations decreases due to damping. And damping is caused by viscous forces due to damping. And damping is caused by viscous forces. And damping is caused by viscous forces. That's all what we need to write down for the answer of this question. Caused by viscous forces. That's all what we need to write down. And this question has only 1 mark. If you write down this, you will get 1 mark. Means this has to be in your answer. You have to mention damping, and you need to say damping is caused by viscous forces. For the second part, it is given to us the mass of the block is 0.57 kg. Use figure 3.3 to determine the decreased delta E in energy of the oscillations for the first half oscillation. For first half oscillation, we have already discussed negative maximum displacement is equal to negative 0.02 meters and positive maximum displacement is equal to 0.016. Now we need to calculate energy. So first thing, let's try to understand what is total energy of oscillation. E total. Total energy of oscillations is equal to kinetic energy plus elastic potential energy. If we talk about equilibrium, at equilibrium, displacement is equal to 0. At equilibrium, displacement is equal to 0. If displacement is equal to 0, it simply means that there is only kinetic energy, means the total energy is only equal to kinetic energy. So EPE is equal to 0. So kinetic energy we can write down. Kinetic energy will be equal to 1/2 m V max, because at equilibrium speed of the block or any oscillator is maximum, and V max is equal to, in simple harmonic motion, is equal to A times omega. So this is V max. So simply we can replace V with A times omega. So this is A omega square of this. So total energy of oscillations is simply equal to 1/2 m A square times omega square. Now for this question we have to find out decrease in energy, means we need to find out delta E, and delta E will be equal to E1 minus E2. E1 means we are talking about this point, and this is over second point. So we can write down equation for E1, so that will be equal to 1/2 m A1 square times omega square. Omega for the system is constant, so we can simply write down omega. And here we have 1/2 m A2 square times omega square. If you look at these two equations, 1/2 m times omega square, this is constant, so we can take this out. So we left with A1 square minus A2 square. Now simply we need to plug in values of A1 and A2 and omega and mass. Mass is given to us, A1 is given, A2 is given. So simply we can write down this is equal to 1/2. So we can plug in value of the mass. Mass of the block is 0.57, but we don't have value of omega square, so we will leave this one for a while. So we can plug in value of A1. A1 is 0.02. This is in meters, so we no need to convert this. So square minus, we have 0.016 square. Now if we have value of omega square, so we will be able to find the change in energy. Now we need to find out value of omega square. If we remember general equation for simple harmonic motion, so we can write down that general equation, and then we can find out value of omega square. General equation of simple harmonic motion simply tells us that A is equal to negative omega square x. But if we compare this one with y is equal to mx, so m, the gradient, that will be equal to negative omega square. So we can write down gradient of this graph, because we have the graph between a and x, so the gradient of this graph is equal to negative omega square. So simply we need to find out value of omega. If we find the gradient, we will take 2 points. We will take this 1 point, and this one we will take over second point. So we need to find out coordinates of these 2 points. If you look at coordinates of this point, we have negative 0.02 comma 2.3, and this point has coordinate 0 comma 0. So in this case we can write down minus omega square. This is equal to gradient, so we can find the gradient of this. So we have 2.3 theory minus 0, and this is divided by negative 0.02 minus 0. So it simply means that omega square is equal to 2.3 divided by 0.02. So we can find out value of omega from here. So this is value of omega. This negative, they are cancelled. So I can cancel this negative with this. So this is value of omega square. And this value we have to plug in here. So we can say this is 2.3 divided by 0.02. So this is omega square. Now we need to simplify this. If we simplify this one, our final answer will be 4.7 times 10 to negative 3 joules, and this is our final answer. So this is the decrease in energy. So this one is decreasing energy. This question has 3 marks. The first mark you will get if you have written this expression. So you will get C1 mark for the energy, total energy of oscillations. And the second mark you will get if you have written omega square is equal to gradient. Gradient is equal to negative omega squared. So you will get second C mark. And the last mark is answer mark. If you have got the right answer, you will get third mark. So this is how marks will be awarded. That's all what we need to understand about this question. Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on electric field from March 2022, Paper 4, Variant 2. In this question, we will discuss what is represented by electric field lines. Then we will discuss how to find, means how to calculate potential at any point between two opposite charges. Mean in the region between two opposite charges, how we can calculate value of potential. Then we will discuss about electric field between two opposite charges. We will also sketch a graph of potential versus distance, and at the end of the video we will also talk about what is direction of force on an electron if it is placed at equal distance from two opposite charges. So we're going to discuss some very important points about this chapter in today's lesson. So listen carefully. First of all, try to do question by yourself and then look at the solution. For part A, we need to state what is represented by electric field line. Let's try to understand this one with the help of positive charge, means the electric field around a positive charge, and electric field around negative charge. So let's say we have negative charge here. So here we have negative charge, and this is the electric field around this negative charge. They have the equal amount of charge, so that's the reason we simply draw 4 for electric field line. This also tells us that they have the equal amount of charge because they have equal number of electric field lines. Now if we need to draw direction of electric field lines, here for positive charges we draw pointing away from positive charge. So we draw arrows like this, pointing away from positive charge. But for negative charge we will draw pointing towards negative charge. We draw arrows like this. This is what question is asking you, why we draw these arrows like this. For positive charge we need to understand why we draw away from positive charge. We follow one convention. Convention is that if we place a positive charge nearby any charge, so these lines tells us direction of force on positive charge. In this case you can see this is a test charge, this is a small charge, so it does not affect the electric field of source charge. So this big charge we call this is source charge. Test charge is very small. Test charge, so the force on this charge you will see it is pointing to the right. So that's the reason we draw these lines pointing away from positive charge. If we place test charge here, test charge has to be positive. So again, repulsive force between these two, and the force is pointing upwards. And same it is true if we place here, anywhere you place in the electric field, the force will be pointing away from positive charge. That's the reason when we draw these arrows, we draw pointing away away. And same is true for the negative charge. But if I place again test charge here, test charge is always positive. If I place positive test charge here, the force on this positive test charge, this is to the left. So that's the reason we draw this arrow to the left. Now if we place positive charge test charge here, there will be attractive force between positive charge and this negative charge. So test charge will be attracted. So that's the reason we draw arrows pointing towards negative charge. So that's the thing you need to understand to answer this question. So simply electric field lines tells us direction of force on positive charge. In this case, direction of force on this positive charge is to the right, and here it is to the left. So this is what electric field lines are telling us. And that's all what we need to write down for this question. And so this is how you can write down your answer. So simply you can say electric field lines tells us direction of force. So you will get 1 mark, 1 B mark. And if you have mentioned on positive charge, you will get second B mark. And there are 2 marks for this question. For part B, it is given to us there are 2 point charges P and Q, and charges are placed at a distance of 0.120 meter apart from each other, as shown in figure 4.1. Charge on P is positive charge and the magnitude of charge is 4.0 nanocoulombs, and charge on Q is negative and the magnitude is 7.2 nanocoulombs. For this question, we need to determine the distance from point P of the point on the line joining the 2 charges where electric potential is 0. Means we need to find a point at a certain distance from P where potential is 0. It means the value of V is equal to 0. Potential is equal to 0. Let's say that point is at a distance of x from P. We just assume a certain distance x, and then we will find the magnitude of x. Means the value of x we will find out. And let's say this distance, if this distance is x and the total is 0.120, so the distance between Q and that point will be 0.120 minus x. Now simply we need to find out what is value of x. Now first of all, let's try to understand a little bit about potential. For positive charges, so I will write down for positive charges, the potential of positive charge is positive. For positive charges, potential is positive. So I will simply say potential is positive. Why potential is positive? Because K is equal to V is equal to KQ over R. If Q is positive, it means V is also positive. Very important point. You need to enter sign. Very important point. For negative charges, we can also say for negative charges, potential is negative. So we can write down here. For negative charges, V is negative. Why V is negative? Because V is equal to KQ divided by R. If Q is negative, it means V is also negative. So simply we can say positive charges produce positive potential and negative charges produce negative potential. Or simply you can say potential of positive charges is positive and potential of negative charges is negative. Very important point. Now let's try to answer this question. It is given to us that we need to find the point where potential is 0 due to these 2 charges. So first we write down the potential of P. So we will say the potential of P plus potential is a scalar quantity. So Vp plus Vq has to be equal to 0. Now Vp we can find out, mean the potential due to positive charge, that is Kq. I will simply say K times Q. Q in this case is 4 nanocoulombs. So this is 4 times 10 to negative 9 coulombs divided by distance. Distance is equal to x. Distance is equal to x. So this is plus sign. So let me clean this one and rewrite. So this is plus sign here. And this is negative charge. So the potential of this one will be negative. So we will use negative sign here. So this is negative 7.2 times 10 to negative 9. And this is divided by the distance. And the distance from this point, I mean the distance between charge and the point is 0.120 minus x. Now from here, the first thing, there are few things we can cancel out. The first thing we can cancel is the k. I'm just using k here, but k you need to understand k is equal to 1 over 4 pi epsilon naught. You can also enter 1 over 4 pi epsilon naught. To keep it just simple, I'm using k. So we can cancel k with k. And the power 10 to negative 9, we can cancel with 10 to negative 9. Now we can simplify this. If we simplify, we're left with 4 divided by x here, and this is negative here. So on other side, this will be positive. So this will be equal to 7.2 divided by 0.120 minus x. Now, if we cross multiply, means we multiply like this. Cross multiply. If we cross multiply, in this case, we will get 4 times 0.120 minus x. This is equal to 7.2 times x. And from here, we can find out, means the value of x will be 0.043 meters. And this is our final answer. Our final answer has 2 SF. Because the least number of SF in data, we have 2. So we are using 2 SF here. So this is our final answer. This question has 2 marks, and the first mark you will get if you have written VP plus VQ is equal to 0. Means you have entered value here. So this mark will be C1 mark. And the second mark is the answer mark if you have got the right answer. So this one is answer mark. For our second part, we need to state and explain without calculations. Means we don't need to do any calculations for this part. Whether the electric field is 0 at the same point at which the electric potential is 0. This question is a bit tricky one. This is testing your understanding of electric field and potential and the relationship between electric field and potential. So first of all, let's try to understand what is the relationship between electric field and potential. Electric field is equal to negative of potential gradient. So simply we can say this is equal to negative delta V over delta R. Now this is the distance. So electric field is the negative of potential gradient. So electric field is 0 if the gradient of V against R graph is equal to 0. Means E is 0. If the gradient of this one means delta V over delta R, this is 0. So simply we can say if the gradient of V against R graph is equal to 0, if the gradient of this one is 0, it means that electric field is equal to 0. If the gradient of V against R graph is equal to 0, it means electric field is 0. Now let's try to sketch first of all electric potential against R. First of all, we will sketch potential against R graph. So V against R. In this case, we have two charges. One charge is positive and one is negative. So I will place the positive charge here. Means this positive charge. So it is placed here. And I will place, let's say, the negative charge. It is placed here. So this one is the negative. So simply let me draw here. This one is the negative charge. This one is negative charge. So this is negative. Positive charge. Its potential is positive. So potential V is equal to KQ over R. Mean R is the distance from the charge. So as the distance from the charge is increasing, the potential of this one will decrease. Now if you look at the negative charge now, the potential of negative charge, this is negative. So it will have certain value, but this value has to be greater because its charge is greater. So its potential will also decrease with distance. But we will see at certain point the potential due to these two charges, we will get graph like this. I mean, if we combine the potential of these two, at this point you will see the potential due to these two charges is 0. But if you look at the gradient of this one, gradient is not 0. So it means at this point potential is 0, but electric field is not 0 because the gradient is not 0. So electric field, we will say, at this point is not equal to 0 because electric field is equal to negative delta V over delta R, and this is not equal to 0. Means the gradient is not 0, but V at this point, this is equal to 0, and that's the point you need to understand to answer this question. So potential can be 0, but at that point electric field cannot be 0. Now let's try to answer this question based on electric field concept. So we will look at that certain point again, and at that certain point we have discussed potential is equal to 0. Now we will look at this point again, and we will find out electric field due to positive charge at this point, and we will find direction of electric field due to negative charge at this point. If you look at direction of electric field at this point due to positive charge, so this will be pointing to the right. So we will say this is direction of electric field due to positive charge. Now if you look at electric field at this point due to negative charge, we will write down this is also to the right because electric field lines are pointed towards negative charges. So electric field due to Q is also to the right and due to P is also to the right. So it means the net electric electric field at this point is the sum of these two fields. So the net electric field will be somewhat like this. So this is our net electric field. Electric field is a vector. So this is our net electric field. Means the sum of vector sum of these two fields. This is not equal to 0. So simply we can say in this case net electric field is not equal to 0 because fields due to P and Q, they are in the same direction. So that's reason E net is not equal to 0. Even potential at this point is equal to 0. And that's all what we need to write down for this question. So this is how you can write down your answer. And in this answer, this is your statement. So you have to write down this one in your answer because question is asking you to state and explain. So this is your statement and this one is explanation. So if you have stated and you have explained, you will get 2 marks. Actually, for this question, we have 1 mark. In order to get this 1 mark, you should have the statement in your answer. I mean, you have mentioned no and you have explained why it is not 0. So you will get 1 mark. And this is B mark. For third part, it is given to us an electron is placed at point X and it is at equal distance from both P and Q as shown in figure 4.2. Means electron is simply placed at this point and it is at equal distance, means the distance between electron and P and the distance between Q and electron, they are the same, but the charge on P is plus 4.0 nanocoulomb, means it has positive charge, but Q has negative charge and this is equal to 7.2 nanocoulomb. As distance is the same but charge is different, so the force on electron due to Q and due to P will be different, but force due to Q will be greater. So we will draw one arrow here because these two charges, they have the same charge. It means there will be repulsive force on electron. So this is force on electron due to negative charge Q, and the force due to charge P, this will be attractive because these two are opposite charges, so the force will be in this direction. So this is attractive force. I draw this arrow shorter because force due to P is weaker than force due to Q. So this is simply, we have these two forces, these are acting on this electron. We simply need to sketch actually, so it doesn't matter. The length of arrows is not very important. To just give you idea how we will draw the resultant force on this one, I have drawn one arrow. This is longer because this force is greater and this force is weaker. Now simply we need to add these two forces. So we will use parallelogram method. So I will take this vector from here, I will just draw here. So I will be using dotted lines. So this is direction of force. Now we will take this vector and we will place here. And now we need to find the resultant of these two vectors. So the resultant is from the tail of these two vectors to the head of these two vectors. So simply tail to head. So we will join this one here. And this is direction of resultant force. And you can see this resulting force is below horizontal. And that's all what we need to do. Simply you need to draw this arrow. So this one is the resultant force on electron. But if these two charges, they were equal in magnitude, then the resultant force will be along horizontal. But in this case, it has to be below horizontal because repulsive force is greater than attractive force. So this is how you can draw the resultant force. Welcome to A-Level and AP Physics. In today's lesson, we will discuss an important past paper question on capacitance from March 2022, paper 4, variant 2. This question is based on new specifications and very important for our coming exam. For question number 5, the variation with potential difference V of the charge Q on one of the plates of a capacitor is shown in figure 5.1. As you can see here, we have charge Q on y-axis and potential difference across plates is on x-axis. It is also given to us the capacitor is connected to 8-volt power supply and two resistors R and S as shown in figure 5.2. So in this case you can see capacitor is connected here. This is symbol for capacitor and this is symbol for power supply. This is 8 volts power supply. Resistor R is connected here at this point and resistor S is connected here. And this is our switch, two-way switch. This switch it can be moved to X, this can also be moved to Y. When the switch is at position X, this capacitor is charging. Very important point, we need to understand when the capacitor is charging and when the capacitor is discharging. In this case, capacitor is charging because there is power supply in this loop, or simply you can say in this circuit. But if we move this switch to Y, this capacitor will start discharging because in this loop there is no any power supply, there is only resistor. So capacitor is at higher potential, it will start discharging. So very important point we need to understand about charging and discharging. Now let's move on to part A and try to answer part A. For part A, question is asking us, the switch is in position X so that the capacitor is fully charged. We need to calculate energy E stored in the capacitor. In E energy stored in the capacitor we need to calculate. So energy stored in a capacitor is equal to 1/2 QV, or we can say this is 1/2 CV square, or energy stored in a capacitor is 1/2 Q square over C. But if you look at this graph, in this case we have value of V and we have value of Q. So simply we can use E is equal to 1/2 QV and we can find out energy stored in the capacitor. Now let's try to understand what value of Q we have to use and what value of V we have to use to calculate energy stored in the capacitor. So the first thing we need to understand is the voltage of the battery, means the voltage of this battery is equal to 8 volts. So when this capacitor is fully charged, means when there is no current flowing in this circuit, at that time the potential difference across the battery and the potential difference across the capacitor, these two potential difference, they will be same. So this is capacitor. So the potential difference across the capacitor, when this is equal to potential difference across terminals of the battery, current flowing will stop. So in this case, battery voltage is 8 volts. So the capacitor voltage also will be 8 volts when this is fully charged. So this is the key concept you need to understand. In this graph, you can see this is the 8 and this is the value of potential difference across capacitor when this is fully charged. So we have value of V and the value of Q is 1.2. So simply you can say you just need to calculate area under this line. So now we can plug in values. We have 1/2 and value of Q is 1.2 times 10 to negative 4 and we need to multiply with value of V, that is 8 volts. So our final answer in this case will be 4.8 times 10 to negative 4 joules up to 2 SF. So this is our final answer for E. This question has 2 marks. You will get first mark if you have used this formula or you have written area under graph. You will get C mark. And the final mark is the answer mark. If you have got right answer, you will get answer mark. So the tricky point, this is the most important point. You need to understand when the capacitor is fully charged, the potential difference across the capacitor can be equal to the potential difference across terminals of power supply. Terminals of power supply. So very important. For part B, it is given to us the switch is now moved to position Y. Means when capacitor is fully charged, we move this switch to position Y. When we move to position Y, this capacitor will start discharging. So simply we can write down now capacitor is discharging. And question is asking us, we need to show that the time constant of the discharge circuit is 3.3 seconds. So how we can calculate time constant? Time constant, we use letter tau for time constant tau, and this is equal to RC. And this R actually is very important. This is resistance of discharging circuit. The resistance of, we can say this is resistance of discharging circuit. Also you can say discharge circuit. Resistance of discharge circuit. Very important point. So in this case, the discharge circuit has a resistance equal to 220 kilo ohms. So simply we can use here R is equal to 220 kilo ohms. So this is value of R. Now we need to calculate value of C as well. But Q is equal to CV. Or simply we can say C is equal to Q over V. C is equal to the charge on one plate of the capacitor divided by potential difference between the plates. So when the charge on one plate of the capacitor is this one, the potential difference across two plates, that is equal to 8 volts. So we can say in this case the capacitance, this will be equal to 1.2 times 10 to negative 4 divided by 8. So this one is capacitance 8.0. Now simply we can plug in value of C and we can calculate tau. So value of C is 1.2 times 10 to negative 4 divided by 8.0. So our final answer in this case is 3.3 seconds up to 2SF. Because this data has 2SF, this also has 2SF. So least number of SF we have 2. So we can say 2SF. And this is our final answer. This question has 2 marks. The first mark you will get if you have used this formula. And the second mark you will get if you have got the right answer. For the second part, it is given to us the fully charged capacitor in A stores energy E. We need to determine the time taken for the stored energy to decrease from E to E by 9. So this question is simply about the relationship between energy and time. But we don't have any direct formula or equation that link energy and time. But we have equations for discharging. We have V as a function of time, means we can find value of V at any given time, mean the potential difference across plates of capacitor by using this formula. And this is the V max, maximum value of potential difference, times E to the power of T over RC. And this is the time constant. We can also use Q as a function of time. This is equal to Q initial value or Q max we can say, times E to the power of T over RC. And T is the time taken. We also have relationship for I as a function of time. This is also equal to I naught, maximum value of I, times E to the power of negative T over RC. We can use them and we can find the value of time. But if we have value of T, then energy, means if we have value of V, when energy becomes E by 9. So first of all, we need to find out value of V. Or we can find value of Q, or we can find value of Y. But in this case, it is easy to find value of V. So we will just focus on V. So we will find out value of V when energy stored in the capacitor is E by 9. So let's start to find out value of V. So we will start from here. Energy stored in a capacitor, let's say this is E naught. This will be equal to 1/2 C V naught square. But in this case, we can write down E naught over V naught square. This will be equal to 1/2 C. The capacitance of capacitor is constant. So simply we can say this will be equal to some constant. We can say that E naught over V naught square, means the ratio between these two quantities will stay constant. So let's say we have the new energy stored, that is E new. We have to find out what is new value of V. Now from here we can find out value of V. E new, as it is given to us, E new is equal to E naught by 9. So we'll write down here E new is equal to E naught by 9. From here we can rearrange, we can write down V new. This will be equal to E new times V naught square divided by E naught. E new is E naught by 9. So this is value of E new. And we have V naught square. And this is divided by E naught. Now from here, you can see we can cancel E with E. So E we can cancel with E. So we left with V naught square divided by 9. Or simply we can say V new. If we take square root on both sides, we will get this is V naught by 3. And that is the value of V nu. And now we can use value of V nu and we can use this equation and we can find out value of T. Now let's try to find out value of T using the formula V as a function of time. This is equal to V max times e to the power of T over RC. Or we can simply say this is equal to V naught e to the power of negative T over tau. And tau is time constant. Value of tau we have already calculated, so we can plug in value of tau. Tau is 3.3 seconds. Now value of V nu, we can rewrite this formula. So V nu, this is equal to V naught e to the power of T over tau. V nu we have calculated, this is V naught by 3 and this is equal to V naught e to the power of negative T over 3.3. So V naught we can cancel, we simply left with 1 over 3. This is equal to e to the power of negative T over 3.3. If we take natural log on both sides, we can say this is 3 to the power of negative 1 e to the power of negative T over 3.3. Now if we simplify this log, we can say this is negative come in front of log, so this is ln of 3, this is equal to negative T over 3.3 because ln of E is 1. So let me write on here ln of E, this is equal to 1. So this negative we can cancel with negative. So T from here is simply equal to ln of 3 multiplied with tau, and our final answer in this case will be 3.6 seconds up to 2 SI. So if you have done this working, you will get 4 marks for this question. The first mark is if you have used the relationship E is equal to 1/2 C V square, you will get 1 mark. So this is 1 mark and this is C 1 mark. And the second mark you will get if you have got the relationship that V nu, this is equal to V naught by 3. So this is an other C mark you will get. And the third C mark you will get if you have used this formula. So if you have used this one, you will get the third C mark. And the fourth mark you will get if you have got the right answer. So this is how you will get these 4 marks. And this question is very important because this is based on new syllabus. Maybe you will see this question in May-June exam as well. Maybe they ask you in a little bit different way, but this concept maybe will appear in coming exam. So try to understand this one and try to master this concept. For part C, it is given to us a second identical capacitor is connected in parallel with the first capacitor. So it simply means that there is another capacitor that is identical to the first one and is connected in parallel with first capacitor. So this is how new capacitor is connected. And question is asking us state and explain the change if any to the time constant of the discharge circuit. So the first thing we need to understand is now in this case when the capacitors are connected in parallel and if two capacitors they are identical, so it simply means that the capacitance is simply double. So you can also imagine like that if we combine these two plates, you see area of the plates increase but the distance between plates is the same. So it simply means that capacitance is double because capacitors are connected in parallel. So we can say capacitance is double. So this is the first point we need to understand. Now the second thing we need to explain is time means the tau. Tau is equal to RC. If the C is double, so it means tau is also double because resistance of discharge circuit remains constant. So it means tau is also double. So that's all what we need to write on 2 points and this question has 2 marks. Let me show you the answer. This is how you can write down the answer. First mark is M mark, means you must get this mark to get the second mark. So if you have written capacitance is double, you will get 1 mark and that is a M mark. And the second mark you will get if you have written time constant is also double. If you simply write down time constant is double but you haven't written first point, you will get no mark. So you have to write down first of all capacitance is doubled, then you can say time constant is doubled because capacitance is doubled. Welcome to A-Level and AP Physics. In today's lesson, we will discuss one very important past paper question on electromagnetic induction from March 2022, paper 4, variant 2. I said this question is very important because this question will challenge your understanding of magnetic flux and your conceptual understanding of magnetic flux linkage. So we will discuss these points in today's lesson. We will also talk about a typical question on Lenz's law, and at the end of this lesson, we will also discuss about electromagnetic induction principle. For question number 6, it is given to us a smaller solenoid is placed inside a larger solenoid, but cross-sectional area and number of turns of smaller solenoid are given. And also we have cross-sectional area of larger solenoid and also the number of turns on larger solenoid. So these informations are given to us. It is also given to us that larger solenoid is connected with DC power supply. As it is connected with DC power supply, it means that magnetic field density, or simply you can say B, is uniform inside the solenoid, inside larger solenoid. So B is uniform and B is constant. So we can say B is uniform and B is constant. It is constant because it is not changing with time, because current is constant. So B inside larger solenoid is uniform and constant. Now let's try to understand what is magnetic flux, because part A is asking us to compare the magnetic flux in the two solenoid. Magnetic flux simply equal to BA cosine of theta, and theta is the angle between B and A. Magnetic flux is equal to BA cosine of theta, and theta is the angle between B and A. B is magnetic flux density, or simply we can say magnetic field density, and A is the area normal vector. Now if you look at the magnetic field inside the solenoid, you can simply see that magnetic field inside solenoid is almost uniform. As you can see here, inside the solenoid, magnetic field is uniform. So the density of magnetic field inside the solenoid is uniform, and the smaller coil is placed inside the larger solenoid. So the B for the smaller solenoid and B for the larger solenoid is the same. So the magnetic flux density for smaller and larger is the same. So simply we can write down in this case flux is equal to BA, because in this case if we take one loop, this is one loop, and magnetic field in this case is passing through this loop. So the angle between B and area normal vector is 0, and cosine of 0 is equal to 1. So simply we can say flux is equal to BA. From here we can say that flux over area normal vector, this is equal to B, but B in this case, this is constant. So simply I can say this is constant. So we can say that magnetic flux for the smaller solenoid divided by area, cross-sectional area of the smaller solenoid, this is equal to the flux of larger solenoid divided by cross-sectional area of larger solenoid. As area of smaller solenoid, this one is small. So if this value is small, so I will say this arrow down means if this value is small, so flux has to be small because the ratio has to remain constant. Now if this area is larger, so this flux has to be larger. So in this case simply we can say as AL, this is greater than AS, so the flux of larger solenoid, this is greater than flux of smaller solenoid. This is what you need to understand. I explain you in detail, so in future you can handle these questions with confidence. Now let's try to write down the answer, and this question has only 1 mark. So here is only 1 mark and this is B mark. So simply you can say flux in larger solenoid is greater, or you can say flux in smaller solenoid is less. So here we have written flux in smaller solenoid is less. If you have written this, you will get 1 mark, and this is the mark. For part B, we need to compare the magnetic flux linkage in the two solenoid. First of all, let's try to understand what is magnetic flux linkage. Magnetic flux linkage is simply equal to N times flux. So this is N times flux. Or simply you can say this is equal to N times BA. Now we need to compare this one. So we can rearrange this one again. So in this case, we can say magnetic flux linkage divided by NA. A is the cross-sectional area and N is the number of turns. This is equal to B. But B for both coils is the same. So we will say this is equal to some constant. So this is constant because B is constant. Now we have to compare magnetic flux linkage divided by number of turns on the smaller coil times cross-sectional area of smaller coil. And this one has to be equal to magnetic flux linkage of the larger coil divided by number of turns on the larger coil times cross-sectional area of the larger coil. So this is simply we need to compare now. But if you look at the smaller coil, so let me rewrite here. So I will rewrite this one. This is the magnetic flux linkage for the smaller coil, and this is divided by number of turns. Number of turns we have 3000 on smaller coil. So number of turns we have here, and the cross-sectional area of smaller solenoid is 1.6 times 10 to negative 3. If we write down for the larger solenoid, we have only 600 turns, and cross-sectional area of larger solenoid, this is 6.4 times 10 to negative 3. Now if you compare these two, means if we compare NS times AS with NL times AL, so this is greater. So if this quantity is greater, it means this one has to be greater, and this one is small, so this one has to be small because the ratio between these two is the same. So here simply we can conclude magnetic flux linkage of smaller solenoid is greater than magnetic flux linkage of larger solenoid, and this is what we need to write down in our answer. So you can multiply, you can find out actually this area is 4 times greater, but number of turns on smaller solenoids are 5 times greater. So it means overall this one is greater. So magnetic flux linkage of smaller solenoid is greater than magnetic flux linkage of larger solenoid. In your answer, simply you can say greater in smaller solenoid, and this is 1 mark. So if you have written this one, you will get 1 B mark. For part C1, we need to state Lenz's law of electromagnetic induction, and this question is very common, most frequently asked in many past papers. So you need to understand how to state Lenz's law in a proper way so you can get full marks. For this question, there are 2 marks, and mostly this question has 2 marks. So you need to understand how those 2 marks will be given and what you need to write down in your answer to get those 2 marks. So let me show you how to state this one. In your answer, you have to mention direction of induced EMF, means the polarity of induced EMF, and this has 1 mark, M mark, and this is must mark, mean you have to state in your answer direction of induced EMF. If you didn't write direction of induced EMF in your answer, you will not get this mark, and you will also not get the second mark because the second mark is depending on the first mark. Then you need to say that direction of induced EMF is such as to oppose the change. You have to mention change because this is underlined, so it has to be in your answer that caused it. You will get the second mark. So this is A mark. Direction of induced EMF such as to produce effects that oppose the change that caused it. If you write down in this way, means in a proper way, you will get these 2 marks. So pay special attention to direction of induced EMF and change because this has to be in your answer. Now let me explain you a little bit about Lenz's law. What exactly Lenz's law is? What does it mean by oppose the change? Imagine that there is a magnetic field. So this is magnetic field that is into the page, and this is uniform magnetic field. And this uniform magnetic field, I will say this is external magnetic field, and direction of this magnetic field is into the page. Now imagine that if this magnetic field is increasing with time, so this is time dependent magnetic field, so this is increasing with time. And now if we place a loop inside this changing magnetic field, if we place loop inside this changing magnetic field, so the magnetic field means the magnetic flux inside this loop will increase. But this loop, they don't like the change in magnetic flux, so they oppose the change. So this is what is meant by oppose the change. Now what is the change here? Magnetic flux is increasing, so this loop will produce current, means current will be induced in this loop, or you can say EMF will be induced. In this case EMF and current, because this is complete loop. So current will be induced in this loop in such a way that it will produce its own magnetic field that will oppose the change, means that will try to reduce the external magnetic field. Now, if external magnetic field is into the page, so the induced magnetic field has to be opposite, means it has to be out of the page. So means it will produce its own magnetic field that will be out of the page. Now, if the magnetic field due to current induced in this loop is out of the page, you can find direction of current, means direction of induced current. You can use right hand grip rule and you can find out direction of induced current, means the B in this case you have to use, this is out of the page, and then you have to use your right hand grip rule and you can find out direction of induced current. So B is out of the page, so your thumb is pointing out of the page, so you need to curl your fingers. So in this case this is counterclockwise and this is direction of induced current. So this is I induced and this is counterclockwise, I will say CCW. This is what is Lenz's law. They oppose the change, and change means in this case magnetic flux is changing, is increasing. So loop will oppose that change. So it will try to reduce flux inside itself. So it will produce its own magnetic field in opposite direction. So this is Lenz's law in a nutshell. I hope this point is clear. Let's move on to next one. For our second part, it is given to us the terminals of the smaller solenoid are connected together. It simply means that these terminals are joined together. Now this smaller solenoid is just like a closed loop. So simply we can say it is a closed loop now, before it was open loop. The smaller solenoid is removed from inside the larger solenoid, means we move this one to the left. So we move this one to the left. We need to explain with reference to magnetic fields why a force is needed to remove the smaller solenoid. This question is also based on Lenz's law. So let's try to understand how we can approach this question. Let's try to do another example based on Lenz's law. So we will use one very simple example so you can understand concept of Lenz's law in a proper way, and then we will use that concept to answer this problem. Imagine that we have a uniform magnetic field and this uniform magnetic field is into the page and we place a loop of wire. This is a conductor we place inside this uniform magnetic field, and this uniform magnetic field is decreasing with time. So our external magnetic field is into the page, but now in this example it is decreasing with time. So this is time dependent. This is decreasing with time. So when external magnetic field is decreasing with time, it simply means that the magnetic flux inside this loop is also decreasing. But this loop will try to maintain the same magnetic flux. It will oppose the change. So in this case, external magnetic field is decreasing. So it will induce its own magnetic field in the same direction, means induced magnetic field also will be in the same direction, mean it will be into the page. So external and induced magnetic field, they will be into the page. Current means magnetic field due to induced current in this loop is into the page. So we can find out direction of current by using right hand grip rule again. So you can use right hand grip rule, but in this case induced magnetic field is into the page. So you can find out direction of induced current. So as induced magnetic field is into the page, so current will flow clockwise in this case. So this is direction of induced current. So this is clockwise. Now if you look at setup of larger solenoid and smaller solenoid, we can simply understand as we move this smaller solenoid out of the larger solenoid, magnetic flux inside smaller solenoid will change. As magnetic flux inside the smaller solenoid will change, there will be induced EMF. But this is a closed loop, so it means there will be induced current as well. And induced current will produce its own magnetic field to oppose the change in magnetic flux. As magnetic flux is decreasing in this smaller solenoid, so I will write down here the B external inside the smaller solenoid. As this one is decreasing, so the B induced and B external, they will be in same direction, and the same point we have already discussed here. So they will be in the same direction. Now we will take the smaller solenoid and larger solenoid. Now imagine that this one is a larger solenoid and this is the magnetic field of larger solenoid. We place place our smaller solenoid first of all here. Then we move this one to this point. So you can see magnetic flux is decreasing inside the smaller solenoid. And then let's say we place our smaller solenoid somewhere here. So the magnetic field of this smaller solenoid due to induced current has to be in the same direction. If you look at larger solenoid, it has north pole here. So it means this side of smaller solenoid has to be the north pole and this side has to be the south pole. If I simply draw these magnetic fields due to these two, I can simply say this is larger solenoid. So it has this side is N and this side is S. I will say this is the largest solenoid because this picture is not very clear. Maybe it will be a little confusing one. This is magnetic field of larger solenoid. I will say this is N, this is S. And the smaller solenoid. So this one is the smaller solenoid. So this is smaller one. Its magnetic field also has to be in the same direction. Mean this side has to be N, this side has to be S. Now you can see S and N, they will attract each other. So it means there will be attractive force on this smaller solenoid. So we have to apply force to move this coil out of the larger solenoid to overcome the attractive force between larger solenoid and smaller solenoid. That's all what we need to understand. So in this case, first of all, we can say magnetic flux changes inside smaller coil. So we can say magnetic flux changes inside smaller solenoid. When magnetic flux changes inside smaller solenoid, it produces its own I induced. I can say it produces its own I induced. And that I induced will produce its own magnetic field. So we will say that I induced will produce its own magnetic field. And magnetic field of induced current and magnetic field of larger solenoid, they will be in same direction. So they will be in same direction and there will be attractive force between these two solenoids due to two magnetic fields, due to interaction between two magnetic fields. So that's all what we need to write down, and this question has 3 marks. So let me show you the answer now. This is how you can write down your final answer. Change of flux linkage in the smaller solenoid induces EMF in smaller solenoid. So we can say magnetic flux change, so it means there is EMF induced in smaller solenoid. And smaller solenoid is a closed loop, so there is also induced current in smaller solenoid. And induced current will cause magnetic field around smaller solenoid, and these two fields, they will interact with each other because one N and S, they will attract each other and there will be attractive force. And that's all what we need to write down about this one. This is a typical type of question. You need to understand this concept. In this lesson, we have discussed Lenz's law in detail. So try to understand these concepts and try to handle questions about this topic with confidence. If you have any questions about this one, if any point is not clear, just leave your question in comments. Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on rectification from March 2022, paper 4, variant 2. In this lesson, we will discuss how to complete full wave rectification circuit, and also we will discuss how to write the equation for sine graph. At the end of the video, we will also discuss how to calculate mean power dissipated in a resistor. For question number 7, part A, it is given to us alternating current is converted into direct current using a full wave rectification circuit. Part of the diagram of the circuit is shown in figure 7.1. For part A, we need to complete the circuit in figure 7.1 by adding components in the gaps, means in these gaps. For the second part on figure 7.1, we have to use plus sign to mark the positive output terminal of the rectifier. This is kind of typical question, and you will see this question in many past papers. So now I will explain you one very important method to handle this type of problems. I will explain this question with the help of answers. So let me show you the answer first, and then I will explain you how you can write down the answer. So this is what question is asking you to complete the diagram. First of all, for part 1, you have to draw these two diodes. This is diode 1, I can say you have to draw here, and this is the second one you have to draw here. And the question was asking you to use the positive sign. So in this case, this is the positive sign. And this one we can say is negative. Positive sign simply tells us means current always will flow. Imagine that this one is a resistor. So simply we can imagine that this is a resistor. So this is DC output. You can imagine there is one resistor. So in this resistor, current will always enter from the side. So that's the reason we mark this side as positive side. Current will enter always from the side. So that's the reason with the help of this circuit, we have converted AC into DC because in this component current flow only in one direction. So this is how we have converted AC into DC. Now let me explain to you how to complete this diagram. So we will look at these points. So first of all, we will look at point A, and let's say this is point B, and let's say this is point C, and this point is point D. Now if you look at point A, it is connected with one terminal of the resistor and B is connected with other terminal. But if you look at these points here, if you look at diodes now, these diodes, they diverge. You see, they are diverging. So these diodes, they diverge. So simply we can say they are diverging at this point, diverge. And where these diodes, they diverge, that is always negative. And if you look at this point, these diodes, they converge to this point. So we can say this point where these diodes converge, and that side is always connected with positive. So this is the point you need to understand. Where these diodes diverge means go away, that is negative terminal of this DC output, and the point where they converge, that is connected with positive terminal of DC output, or you can say resistor, and remaining two terminal you can connect with AC input. So this point, other 2 points, points C and D, they are connected with AC input, and this is true for any shape of bridge rectifier circuit. How they draw, it doesn't matter. If it is a full wave rectifier circuit, you can just follow these points. Where diodes diverge, that has to be negative terminal of DC output. Where they converge, that one has to be positive terminal of DC output. And the remaining 2 points, you can just simply connect with AC input. And this is how you can answer. Let me know if you have any questions about full wave rectifier circuit in comments section. For part B, the output voltage V of an AC power supply varies sinusoidally with time as shown in figure 7.2. So as you can see, simply this is a sinusoidal graph, or this is simply a sine graph. In this case, you can see on y-axis we have voltage and on x-axis we have time. For part 1, question is asking us to determine the equation for V in terms of T, where V is in volts and T is in seconds. So if you look at this graph, this is a sine graph. So we can write down the equation for sine graph. So V as a function of time, this will be equal to V naught, means the maximum value of V, times sine of omega t, sine of omega t. Now we need to plug in values of V naught and omega. First of all, the value of V naught means the V max we can read from here. V max is equal to 3.5. So simply we can write down V naught is equal to 3.5 volts. Now we need to find out value of omega. That omega is equal to 2 pi over t, and t is the time period. Now if you look at this sine graph, this is one complete cycle. So this is one complete cycle. So we can read the time period from here. Time period in this case is equal to 2.5. So we can replace capital T with 2.5. So this is time period 2.5. If we simplify this one, means 2 divided by 2.5, and this is multiplied with pi. So we will get 0.8 pi, and this is value of omega. Now simply we can replace V naught with 3.5 sine of omega t, and omega is equal to 0.8 pi times t, and that's all what we need to write down for this question. And this question has 2 marks. This question has 2 marks, and the first mark you will get if you have got the right value of omega. So this is C mark, and the second mark is A mark. If you have got the right equation, you will get the second mark, and this is A mark. But if you have got the right answer, so still you will get 2 marks, even you haven't written this one, so you will get 2 marks. But if your answer is wrong, you have calculated value of omega right, you will get 1 mark. For the second part, it is given to us that the power supply is connected to 12 ohm resistor, and this is the output of the power supply. And question is asking us to calculate the mean power dissipated in the resistor. So we have to calculate the mean power dissipated. So simply we can say this is P mean. In order to calculate P mean, we have to use RMS value of the V. So we can say V RMS square divided by R. So this is how you can calculate that V RMS. So let me write on here V RMS. This is equal to peak value of V means V naught, or simply you can say the peak value of V divided by root of 2. Now we can replace V RMS with peak value. So we can say this is the peak value divided by root of 2 and the square of this, and this is divided by R. Now if we simplify this one, we can say this is V peak value of V square divided by 2R. And now we can plug in values of peak value and resistor. So in this case, the peak value is 3.5. We have already discussed. This is peak value 3.5. Peak value is 3.5, and this is divided by 2 times the resistance of resistor. And now we can simplify and we can get the final answer. In this case, the final answer will be 0.51 watts, and this is the final answer. This answer has to be up to 2 SF because this has 2 SF and this also has 2 SF, least number of SF. So this is our final answer for this question. This question has 2 marks. If you have written the right formula, you will get 1 mark, and that is C1 mark. And the second mark is answer mark. If you have got the right answer, you will get the second mark. Welcome to A-Level and AP Physics. In today's lesson, we will discuss one very important past paper question on quantum physics from March 2022, paper 4, variant 2. In this question, we will discuss de Broglie wavelength, electron diffraction, and wave nature of electron. We will discuss when electron behave as a wave and when electron behaves as a particle. So these important concepts we will discuss today by solving past paper questions. For question number 8, part A, we need to state the formula for the de Broglie wavelength of a moving particle. We need to state the meaning of any other symbol used, means other than lambda. So if we write down the formula for de Broglie wavelength, lambda is equal to h over p. P is the momentum. You can also write down this one h over mv. For example, if you write down h over p, then we have to state what is h. So h is Planck constant. So you have to write down h is Planck constant. So simply we can say h is Planck constant. And for p is momentum of moving particle. So we can say p is momentum of moving particle. So p is momentum of moving particle. So simply we can write down p is momentum of moving particle. You can also write down momentum of moving particle if you have written mv. So you can say mv is momentum of moving particle. So you can also write down, you can say momentum of particle, momentum of moving particle. You can also explain, you can say m is mass of particle. You can say m is mass of particle and v is speed of particle. So you can also explain it this way. So you can say v is speed of particle, or you can say is velocity of particle. So speed, or you can say is velocity of moving particle. So this is how you can answer this question. This question has 2 marks. The first mark is M mark. So you will get first mark if you have written this formula. And the second mark is answer mark. You will get if you have explained the symbols other than lambda. So second mark is answer mark. But if you didn't write this formula or your formula is wrong, you will get 0 m. Then even if you have written h is Planck constant and p is momentum of moving particle, you will get 0 mark. Answer mark you will not get. So you have to get m mark to get answer mark. If you have written this formula right, you will get 1 mark. If you didn't explain these symbols, you will get this 0 mark. Answer mark will be 0. But if here you got 0, even this is right, still you will get 0. So m marks are very important. You cannot get a mark if you can't get m mark. For part B, it is given to us electrons accelerate through a potential difference pass through a thin crystal and then are incident on a fluorescent screen. The pattern in figure 8.1 is observed on the fluorescent screen. Means electron pass through the crystal and we observe these circles. We observe this kind of pattern. For part B1, we need to state the name of the phenomenon shown by the electrons at the crystal. Electron behave as a wave and electron also behave as a particle, but it depends on conditions. So electrons behave as waves and electrons also behave as particles, but it depends on the conditions. If you get this pattern, in this case electrons are not behaving as particles because electrons spread out. As electrons spread out, so this is telling us electrons are behaving in this case as waves, because particles do not spread out. If electron was behaving as a particle, so we should see electrons only here, but in this case we see electrons, they spread out, they form this pattern. As electrons spread out, so this phenomenon is diffraction. As electrons spread out in this case, so we can say this is electron diffraction. So simply we can say this phenomenon is electron diffraction. So simply we have to write down this phenomenon is electron diffraction because electrons spread out in this case. The second thing you can also understand, these are two crests and the distance between these two crests is equal to lambda. So it simply means that in this case electrons are behaving as wave. So we can say in this case electrons behave as wave. Now if you go to the second part, question is asking us to state what this phenomenon shows about the nature of electrons. Nature of electron we have already discussed. In this case electrons are behaving as waves. So simply we can say moving electrons behave as waves. So we can say moving electrons behave as waves. Electrons behave as waves. It depends on conditions, behave as waves. And if we need to find the value of the lambda, so lambda is equal to h over p, means the momentum of electron. If we have momentum of electron, we can calculate lambda. So h over mv. M is the mass of electron. So this is how we can answer this question. This question has 2 marks, means 1 mark for part 1. So this is B1 mark. And the second one is also B1 mark. For the third part, we need to suggest why the thin crystal causes the phenomenon in B1, means electron diffraction. Why we observe electron diffraction? Now we need to explain that one. First thing we need to understand, significant diffraction takes place. Significant diffraction. We need to understand condition for significant diffraction. Condition for significant diffraction is when gap size is almost equal to the lambda of the wave is equal to wavelength, then we observe significant diffraction. So we have to write down the same thing here as well. In this case, gap size means spacing between atoms, or you can say atomic spacing between atoms. So in this case, spacing between atoms, if that spacing is approximately equal to the wavelength of electron, then electron diffraction is possible. In this case, we observe electron diffraction. So it means that spacing between atoms is almost equal to wavelength of electron. So that's the reason we observe electron diffraction. So this is the point you need to write down. And this question has 1 mark. So this is our answer for this question. For part 4, it is given to us the electron is accelerated through a different potential difference. The new pattern observed on the screen is shown in figure 8.2. And this is our figure 8.1. So this is figure 8.1. And this is new figure 8.2. State and explain the change that has been made to the potential difference to create the pattern shown in figure 8.2. So we need to explain the change made to potential difference. Means the potential difference has been increased or potential difference has been decreased. So we have to state that. Then we have to explain that. Potential difference has been increased or potential difference has been decreased. This is what we need to state. And then we need to explain. State and explain. And this question has only 2 marks. 1 mark for stating, 1 mark for explaining. So let's try to observe the difference between these two patterns. If you look at new pattern, so this is wavelength here. So this is new pattern. We can say this is lambda new. If you look at old pattern, this is the wavelength. And we can say this is lambda old. Lambda old. In this case, it is very clear that lambda new is shorter than lambda old. If you look at de Broglie wavelength, in de Broglie wavelength equation, we have discussed that lambda is equal to h over p. If lambda has decreased, it means momentum has been increased. So first thing we can observe from here is that lambda has been decreased, so momentum of electron has been increased. Now we need to understand the relationship between kinetic energy and momentum. Kinetic energy is equal to momentum square divided by 2m. So if momentum of electron has been increased, it means kinetic energy of electron has been increased as well. And in this case, kinetic energy is given by electrical energy. Is given by electrical energy. So we can say this over electrical energy. And electrical energy is equal to Q times delta V. In this case, kinetic energy has been increased, so it means we have to supply more kinetic energy to electron. Electrical energy has been increased, but the charge of electron does not change, so it means the potential difference has to be increased. So that's all what we have to write down for the answer of this question. So we will say in this case, accelerating potential difference has been increased because momentum of particle means momentum of electron has been increased because its wavelength has been decreased. That's all what we need to write down. Let me show you the answer, how you can write down answer for this question. This is how you can write down answer. So the first thing you need to state. So simply you can state in this case, this is the statement. Accelerating potential difference has been increased. And then you need to explain this one. So you will say wavelength has been decreased, so momentum of electron has been increased. Simply you can say electron has greater momentum. The first mark is M mark, means this explanation. So you have to explain in a right way. If you have explained in a right way, then you will also get the answer mark. If your explanation is wrong, even you have written potential difference has been increased, you will get 0 mark. So if you got 0 mark here, M0, this also will be 0. Even you have written potential difference has been increased. So your statement has to be right and your explanation has to be right. Then you will get 2 marks. But if your statement is right, but your explanation is wrong, you will get 0 mark. Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on nuclear physics from March 2022, paper 4, variant 2. In this question, we will discuss how to complete the nuclear equation for alpha decay, how to calculate nuclear activity, and how to sketch graph of daughter nuclei against time. At the end of this lesson, we will also discuss how to calculate energy released in a nuclear decay. So in this video, we will discuss some very important point about nuclear physics. So listen carefully and try to improve your understanding of this topic. For question number 9, it is given to us polonium-211 decays by alpha emission to form a stable isotope of lead. For part A, we need to complete the equation for this decay. It is given to us this is alpha decay. So first of all, we can write down atomic number and mass number for alpha particle. Now we have to complete this one. So this is 84 minus 2. So this one has to be 82. And this is 211 minus 4. So this one has to be 207. So that's all what we need to do. And this question has 2 marks. If you have done this right, you will get 1 mark. And if you have done this right, you will get the second mark. For part B1, it is given to us at time t is equal to 0. Sample only contains polonium-211. For part B1, we need to use figure 9.1, means we have to use this figure, and we need to determine the decay constant lambda of polonium-211. Give a unit with your answer, means we have to write down the unit for answer as well. Now this question is asking us to calculate decay constant. Decay constant simply is equal to ln 2, or simply you can say ln 2 divided by half-life, but ln 2, this is equal to 0.693 divided by half-life. So this is divided by half-life. Now simply we need half-life. If we have value of half-life, we can calculate decay constant. In order to find half-life, we need to use figure 9.1. So we can write on here, this is 0.693. We have to divide by half-life. Initially, we have 24 number of nuclei, 24 times 10 to 12 number of nuclei. So when these nuclei become half, means they become 12. That time taken, that is equal to half-life. So simply you can read this one from here. This is 0.52. So this is half-life, and half-life is in seconds. So simply we can write on here. So this is 0.52 seconds. So we will write on unit here as well, lambda. Now we have to simplify this. If we simplify this one, our final answer will be 1.3 per second, because this is in denominator. So this one is over answer. This is how you can calculate. Let me explain you a different method to answer same question. If you want to use a different formula, you can use this one. You can use n is equal to n naught e to the power of negative lambda t. And t is the time taken for n naught to become n. So this is value of t. For example, in this case, we have n naught that is equal to 24, and you want to use n is equal to 10. So you can take value of t from here. So in this case, this one will be the value of t, and you can use this value of t, and you can use this formula, and you can calculate value of lambda. But you also need to understand the derivation, means we can use this formula and we can derive this one as well. So this formula we can derive from this basic formula. So let's try to understand how we can derive formula. But if you're curious to use this formula, you can take any value of t, means the time value of t when n naught, initial number of nuclei, they become n. You can use that value of t instead of using half-life. You can find value of lambda, but this will be a little bit long method, and this one is smart way to answer this problem. If half-life is given, lambda is given, you can calculate half-life. If half-life is given, you can calculate lambda using this method. You using this equation. Let's try to derive this one. Imagine that n naught, this decays to n naught by 2, means half number of nuclei decay. So then we can write down e to the power of lambda, and the time taken, that will be equal to 1 half-life. So in this case, we can cancel n naught with n naught. So we left with 1 by 2, and this is equal to e to the power of negative lambda times 1 half-life. Now, if we take natural log on both sides, ln of 1 by 2, and here we take ln of e to the power of negative lambda times 1 half-life. Ln 1 by 2, we can write down ln 1 by 2. This is equal to ln 2 to the power of negative 1. So we can say negative ln 2. So minus sign in front of ln 2. So we can simplify this. We can say this is negative minus sign here, ln 2. And this is equal to ln e. But ln e, you need to understand, ln e is equal to 1. So ln e is equal to 1. As ln e is equal to 1, so simply we left with minus lambda t times half-life. So this negative we can cancel with this negative. Now simply we can write down in this case lambda is equal to ln 2 divided by half-life. So this is how we can derive this formula. Ln e is equal to 1. So this is also important point. You need to understand ln e is equal to 1. Simply you can say ln and e, they cancel each other. For the second part, we need to use answer from B1 to calculate the activity at time t is equal to 0 of the sample of polonium 211. We need to calculate activity, and activity is equal to A times lambda n. We have to calculate activity at time t is equal to 0. So here we have time t equal to 0, and we have number of nuclei. So at t is equal to 0, we have number of nuclei, that is equal to 24 times 10 to 12. And value of lambda we have calculated in part B1. That was equal to 1.3 per second. Now simply we have to multiply these two. So we can plug in value of lambda times n. N is equal to 24 times 10 to 12. So if we simplify this, our final answer will be 3.1 times 10 to 13 per second, or simply we can write down BQ, means number of decays per second, BQ, background. That's all what we have to do for this question. If you got right answer, you will get 1 mark, because this question has only 1. So this is our final answer, up to 2 SF, because least number of SF in raw data we have 2. So our answer also has 2 SF. So we can say 2 SF. For the next part on figure 9.1, we need to sketch a line to show the variation with time t of the number of lead nuclei in the sample. But for this question, it is given to us that polonium decays into stable isotope of lead. It simply means that total number of nuclei at any given time has to be equal to number of polonium nuclei plus number of Pb, means lead. By keeping this fact in our mind, we can sketch the graph. So the graph will be just reflection of given curve. So let me show you how you can sketch the graph. This is how you can sketch the graph. Now if you look at this point, we have 12 nuclei of lead and we have 12 nuclei of polonium. And if you look at T is equal to 0, we have 0 nucleus of Pb and we have 24 nuclei of polonium. And this is true. You can also check at any point. This has to be true. So this is how you need to sketch the curve. So this is blue curve you have to sketch. So this is for number of nuclei of lead. So this curve you have to sketch. So you have to be careful with this point. You have to be careful with this point. Now if you look at this one now, at polonium, you can see this is one big square and three small square. And if you look at this one, we have one big square and we have small 3 square. So it simply means that it's just reflection. So this curve curve is just reflection of keyword curve. For part C, it is given to us each decay releases an alpha particle with energy 6900 kilo electron volts. For part C1, we need to calculate in joules the total amount of energy given to alpha particles that are emitted between time t is equal to 0.3 seconds and time t is equal to 0.90 seconds. So the first thing we need to understand, it is given to us that number of alpha particles emitted, we can say number of alpha particles emitted. Number of alpha particles emitted is equal to number of decays. Number of decays. Or simply we can say is equal to number of polonium nuclei decayed. Number of polonium nuclei decayed. So this is very important point. So number of alpha particles emitted, we can simply calculate. That is equal to number of polonium nuclei decayed. At time t is equal to 0.3 seconds, we have this much number of polonium nuclei. And at time t is equal to 0.9 seconds, we have this many number of polonium nuclei. So we can calculate number of alpha particles emitted. So simply we have 16 times 10 to 12 minus we have 7.2 times 10 to 12. So here we have number of alpha particles emitted. Now we need to find out total energy given to alpha particles. Total energy given to alpha particles. So we can write down here total energy given to alpha particles, and that is equal to number of alpha particles times energy released in one decay or energy given to alpha particle in one decay. So simply we can write down here this is 16 times 10 to 12 minus we have 7.2 times 10 to 12. We have to multiply this one with energy given to alpha particle in one decay. That is equal to 6900 kilo electron volt. Now we have to convert 1 kilo electron volt into joules, and 1 kilo electron volt is simply equal to 1.6 times 10 to negative 19. This is kilo, so we have to multiply this one with 3. So simply we can say this will be equal to 1.6 times 10 to negative 16. So we have to multiply here with 1.6 times 10 to negative 16. So if we multiply this, we can find out our final answer. So the final answer in this case will be equal to 9.7 joules, and this is the energy given to alpha particles in this number of decays. So this is our final answer. So this is very important point you need to understand. So in this case we can say 1 is equal to 1.6 times 10 to negative 16 joules over kilo electron volts. So this factor you have to understand. For the second part, we need to suggest why the total amount of energy released by the decay process between t is equal to 0.3 second and t is equal to 0.9 second is greater than the answer in C1. So it simply means that we can write down here total amount of energy released, E total released. This one is greater than energy of alpha particles. So we need to explain where extra energy has gone. So we can write down here, first of all, extra energy. Extra energy, in fact, become kinetic energy of Pb nucleus plus gamma photons. So we can say gamma radiations, or you can say gamma photons, gamma radiations. So in any decay, gamma radiations are always emitted. So the extra energy has gone to kinetic energy of lead nucleus and in form of gamma radiations. Now let's try to understand how it becomes kinetic energy of Pb. Polonium nucleus, initially this is at rest. So this nucleus is at at rest. So I will redraw here polonium. Polonium initially is at rest. So U is 0. So the momentum of this one, Pi, is also 0. So momentum has to be conserved in any decay. So after this decay, we have two particles. One is nucleus of Pb and one we have alpha particle. So if alpha particle go, for example, if alpha particle go to the right, Pb has to go to the left to conserve momentum. So Pb has kinetic energy. So all the energy is not the kinetic energy of alpha particle. Energy released in this decay become kinetic energy of alpha particle. It also become kinetic energy of Pb, and also it is energy of gamma radiations. So final momentum has to be conserved. So P final has to be equal to P initial. So that's the reason these particles have to go in opposite directions. In this case, most of the energy will go to alpha particle because it has very small mass, and less kinetic energy will go to lead because it has higher mass. But momentum of alpha and momentum of Pb has to be the same and in opposite directions. So this is the reason. You can write any one of them. So let me show you how you can write down the answer. You can say it becomes kinetic energy of Pb, or you can say it is released in form of gamma radiations, or you can say in form of gamma photons. Any one point you can write down. So this is how you can write down your answer. This question has 1 mark. So if you write down lead nuclei have kinetic energy, you will get 1 mark. Or if you write down gamma photons are also emitted, so the extra energy is energy of gamma photons, you will still get 1 mark. So this is how we can answer this type of problem. Welcome to A-Level and AP Physics. In today's lesson, we will discuss one important past paper question on medical imaging. And this question is from March 2022, paper 4, variant 2. In this question, we will discuss some important points about X-rays, especially how X-rays can be used to form image and what's difference between good contrast and poor contrast. For question number 10, it is given to us in an X-ray tube, electrons are accelerated through a potential difference of 75 kilovolts. The electrons then strike a tungsten target of effective mass 15 grams. The electron energy is converted into energy of X-ray photons with an efficiency of 5%. The rest of the energy is converted into thermal energy. The X-ray tube produces an image using a current of 0.40 amps for a time of 20 milliseconds. The specific heat capacity of tungsten is given. We need to determine the temperature rise of the tungsten target. So in this case, first thing we need to understand is electrical energy means the energy supplied. So we can simply write down electrical energy. This has been converted into X-rays photons. So we can say electrical energy has been converted into X-rays photons. And the efficiency of that one is 5%. So it means 5% of electrical energy is used to produce X-ray photons. So simply we can say X-ray photons. And 95% electrical energy is used to produce thermal energy, means it's converted into thermal energy. So simply we can write on here thermal energy, 95%. We need to calculate the rise in temperature. So simply for this question we have to use Q is equal to MC delta T. Q is the amount of thermal energy, but the thermal energy is equal to 0.95 of electrical energy, and electrical energy is equal to VIT. So this is electrical energy, and this is equal to MC delta T. MC delta T. We need to calculate value of delta T. We can rearrange this. We can write down 0.95 and VIT. V is the potential difference, I is current, and T is temperature. temperature, and this one has to be divided by MC. So in this case, we have value of V. We need to plug in value of V. V is equal to 75 kilovolts. So we have to multiply this with 1000. And current is given, that is 0.40. Time is 20 milliseconds. So we have to multiply with 10 to negative 3. And this one has to be divided by MC. The mass is given, that is equal to 15 grams. So we have to convert into kilograms. And the value of C is given, that is 130. And now we just need to simplify. If we simplify this one, our final answer will be equal to 290 Kelvin up to 2 SF. Because we have least number of SF 2, so our final answer also has to be up to 2 SF. So this is our final answer. This is how we can calculate. For part D, it is given to us the linear attenuation coefficient of X-ray photons in muscle is 0.22 per centimeters. We need to calculate the thickness of muscle that will absorb 80% of the incident X-ray intensity. So first of all, imagine that we have muscle. So this is muscle, and the intensity incident on this one is I naught. So this is incident intensity, and the intensity of X-rays transmitted through this one, let's say, is I. 80% has been absorbed by this muscle. So 80% has been absorbed. So the I transmitted will be equal to 0.20 I naught. Means only 20% has been transmitted through this muscle. So by using these informations, we can calculate thickness. So first thing we need to understand how I transmitted. This is linked with I incident. So we can say this is I transmitted. This is equal to I incident. So we can simply write down. So this is I incident times e to the power of negative mu times t. Mu is coefficient, t is the thickness. So we can simply write down this. I is equal to I naught e to the power of negative mu times t. Now we need to simply plug in values. I is equal to 0.20 times I naught. Here we have I naught e to the power of negative mu times t. We can simply cancel I naught with I naught. So we left with 0.20, and this is equal to e to the power of negative mu times t. Now if we take ln on both sides, we can take ln here. So this is 0.20, and we can take ln on this side. So we'll get this is negative mu times t ln of e. Ln of e is equal to 1. So ln of e, this is equal to 1. So simply we left with ln of 0.20. This is equal to negative mu times t. But we need to calculate value of t. So this will be equal to ln of 0.20 divided by negative mu. So we can plug in values. So you can use calculator. You can get value of ln 0.20 divided by negative value of mu. Mu is 0.22. So if we solve this, our final answer has to be 7.3 centimeters. And this is our final answer. For part C, it is given to us table 10.1 shows the linear attenuation coefficient for the X-ray photons in different tissues. Value of mu for different media is given to us. Two X-ray images are taken, one of equal thickness of bone and muscle, another of equal thickness of blood and muscle. We need to explain why one of these images has good contrast but the other does not. First thing, let's try to understand how we can get a good contrast. So we will write down here good contrast. When we can get good contrast. Good contrast is possible if mu for two media is totally different. So we can say if mu for two media are very different. So we can say very different. It simply means that, let me write down in a simple way. It simply means that if mu1 is much greater than mu2, and vice versa is also true. If mu2 is much greater than mu1, means value of mu's are very different. So in that case, they will absorb very different amounts of X-rays. So in that case, we can say two media, they will absorb very different amounts of X-rays. So we'll say absorb very different amounts of X-rays. So we will have good contrast. So these are the conditions for good contrast. Now also let's try to discuss when we will get poor contrast. It is just opposite. So let me write down poor contrast. So it means values of mu's are very close to each other. Means mu1 is about equal to mu2. Means very close. So the mu for two media are very close to each other. So in that case, they will absorb almost same amount of X-rays. So almost same amounts of X-rays. So we will have poor contrast. Same amounts of X-rays. So we will have poor contrast. Now we have to use this knowledge and we need to answer this question. So first of all, look at bone and muscle. For the bone, the value of mu, let's say this is mu1, is given 3.0. And if you look at muscle, for the muscle is 0.22. So we can see there is a big difference between these two. So in this case, we will have good contrast. So simply we can say we will have good contrast. But if you look at muscle and blood, means for the blood we have 0.23 and for the muscle we have 0.22. So these two are very close to each other. So it means in this case we will have poor contrast. So that's all what we need to understand to answer this question. I mean, this is the knowledge, or simply we can say these are the concepts you need to answer this question. Now let me show you how you can write down a good answer. This is how you can write down the answer for this question. First thing you can say, linear attenuation coefficient are very different for bone and muscle, as you can see here, for bone and muscle. And this is M mark. You have to write down this one. Second one, so they will absorb very different amount of X-rays, so we will have good contrast. You see, in a systematic way, you can write down your answer. You can also write down, so this is one way. If you write down this one, you will get 2 marks. Another way to explain this one, you can also say linear attenuation coefficients are very similar for blood and muscle, as you can see for blood and muscle. So in this case, they will absorb similar amounts of X-rays, so poor contrast. So this is how you can answer, and this understanding is very important. Let's look at this image now. If you look at this part, you can see this contrast. This is poor contrast, less difference in degree of blackness, poor contrast. So this is poor contrast. But if you look at this one, this has good contrast. So this one has good contrast, means one is absorbing a lot of X-rays. In this case, bone absorb a lot of X-rays. The screen behind means X-ray film stay white, but muscle absorb very less amount of X-rays. So the film means X-ray film behind muscle is black because a lot of X-rays just pass through muscle directly. Muscle does not absorb a lot of X-rays. So this is, you can see, is good contrast, and this one is poor contrast. Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on PET from March 2022, Paper 4, Variant 2. In today's class, we will discuss what is meant by tracer, means how we can define tracer. Then we will talk about annihilation process. We will discuss what is annihilation and what kind of particles are involved in annihilation. Then we will talk about image, means how we can create image using PET PET scanning, and also we will do some calculations about PET. So in today's class, we will discuss some very good points about PET, means we will discuss some important concepts, and those concepts you need for your exams. For question number 11, it is given to us PET scanning obtains diagnostic information from a person. The information is used to form an image. PET scanning uses a tracer. We need to explain what is meant by tracer. So let's try to understand, first of all, in a very simple way, what is tracer. Tracer simply is a substance containing radioactive nuclei. So simply we can say tracer is a substance containing radioactive nuclei. So we can say substance containing radioactive nuclei. So tracer is substance that contains radioactive nuclei, and that substance is injected into the body of the patient. So we call this one tracer. We can use that substance to locate the position of tumor or something else in the body of patient. Now let's try to understand a little bit more about this one. Tracer we use in PET is called FDG, means fluorodeoxyglucose. So what is fluorodeoxyglucose? First thing we need to understand is a normal, means the common glucose. So this is structure of common glucose. But if we replace OH with fluorine 18, and fluorine 18 is radioactive nuclei, so then we call glucose is FDG, and FDG is a tracer, and that is injected into the body of the patient. And FDG is a beta plus emitter, or we can say this is positron emitter. Positron emitter. So this is positron emitter, and positron is antiparticle of electron. So we can say this is antiparticle of electron. Antiparticle of electron. So I will be writing electron here. So we use fluorine 18 because it emits positron, and positron is antiparticle of electron. Now let's try to define how we can write the answer for tracer. So simply you can write down substance containing radioactive nuclei, and this is injected into the body of the patient. So let me show you the answer. This question has just 1 mark. So this is how you can write down your answer. So you can say tracer is a substance containing radioactive nuclei, that is introduced into the body of patient. If you write down this one, you will get 1 mark. Let's move on to second part. For second part, it is given to us. For part B, PET scanning involves annihilation. Explain what is meant by annihilation. Annihilation simply means that in annihilation, mass converted into energy. So mass is converted into energy, and that process we call is annihilation. Means when mass is converted into energy, that process we call is annihilation. Now we need to understand how mass can be converted into energy when particle and antiparticle they meet. Means when positron, that is emitted by fluorine 18, positron, when it meets with electron, positron, when it interacts with electron, they annihilate, and only energy is produced. They annihilate and energy is produced, and this energy is produced in form of gamma photons. So means 2 gamma photons will be produced in this case, and these gamma photons, they have to move in opposite directions to conserve momentum. So this is what we need to understand about annihilation. Means when particle, so this is antiparticle, when particle and antiparticle they interact with each other and they are converted into energy, that process we call is annihilation. So let me show you how you can write down the answer. So first thing we need to understand, PET scanning involves annihilation. Explain what is meant by annihilation. Annihilation simply means that in annihilation, mass converted into energy. So mass is converted into energy, and that process we call is annihilation. So let me show you how you can write down the answer. This is how you can write down your answer. So simply you can say a particle interacting with its antiparticle so that mass is converted into energy. So this is how you can define what is annihilation. Let's move on to next part, second part. State the names of the particle involved in the annihilation process. We have already discussed positron and electrons. So simply you can write down here for this question, you can say positrons and electrons. Positrons are emitted from FTG, means fluorine. It emits beta plus particle, means positron, and they interact with electron in the body of the patient. So electron in the body of the patient. So these are in patient's body. So we can write down in the patient's body, and positron is coming from FTG. That's all what we need to write down for the answer of the second part, positrons and electrons. So these are the particles that are involved in annihilation process, and this question also just has 1 mark. So this is how you can write down a proper answer. For part C1, we need to calculate the total energy released in one annihilation event in B, and annihilation takes place when antiparticle interact with particles. So in this case, imagine that this is antiparticle, and here we have particle, means we have electron. So when antiparticle interact with particle, annihilation takes place. So in this case, mass will be converted into energy, and in this case 2 gamma photons will be emitted to conserve momentum. So this is 1 gamma photon, this will go in one direction, and other gamma photon, this will go in opposite direction, simply to conserve momentum. Now for this question, we need to calculate the total energy released. In this case, we have 1 positron and we have 1 electron. The mass of positron, so we can say mass of positron, this is equal to mass of electron. Particle and antiparticle, they have the same mass. So the mass of positron and mass of electron is equal to 9.11 times 10 to negative 31 kgs. And this is mass of one particle. But in this process, 2 particles are involved. So we can say the mass total in this process is equal to mass of positron plus mass of electron. Or simply we can say this is 2 times mass of electron. So this is the total mass involved. And we need to calculate energy, total energy released. So E simply will be equal to M total. So we can say M total times C square. E is equal to mc square, and total mass is equal to 2 times mass of electron times c square. Now simply we need to plug in these values. So simply we can say in this case E is equal to 2 times mass of single electron times c square. So c is equal to 3.00 times 10 to 8 square. Now if we simplify this one, we can find out our final answer, that will be equal to 1.64 times 10 to negative 13 joules. So this is the total energy produced in this process. So this is our final answer, 1.64 times 10 to negative 13 joules. Now let's move on to second part. For the second part, we need to calculate wavelength of each gamma photon released. So in this case, 2 gamma photons are released. So the energy of 1 gamma photon, so we can say energy of 1 photon, gamma photon, or simply we can say energy of 1 photon, that will be equal to E by 2. So simply we can write out here energy of 1 photon, this is equal to hc over lambda, and we need to calculate lambda in this case. So lambda will be equal to 2hc divided by E. Now simply we need to plug in values. So in this case we have 2, and this is multiplied with h. H is Planck's constant, and the value of Planck's constant is 6.63 times 10 to negative 34 and C is constant, that is equal to 3.0 times 10 to 8, and we need to divide by E total. E total is 1.64, means the answer we have got in C1 times 10 to negative 13. If we simplify this, our final answer will be 2.43 times 10 to negative 12 meter. So this is wavelength of single photon. So our final answer is 2.43 times 10 to negative 12 meters, and this is our final answer. This is how we can calculate lambda for a single photon. For part D, we need to explain how the gamma photons are used to produce an image. First thing we need to understand when gamma photons are produced. Gamma photons are produced due to annihilation process. Annihilation. When annihilation takes place, gamma photons are produced. So simply we can write down gamma photons are produced. Due to annihilation, gamma photons are produced because mass is converted into energy. And these gamma photons, they are detected by detector outside of the body. So we can say gamma photons are detected outside of the body by detector. So we can say detected outside of the body. They are detected outside of the body of the patient. So here these are detectors. So this ring consists of detectors. We can say this ring consists of detectors. And these gamma photons are detected outside of the body. And if we look at annihilation process, here annihilation is taking place. So here annihilation is taking place. So simply I will draw arrow here. At this point annihilation is taking place. And gamma photons, they travel in opposite directions. Let's say this distance is L1, means distance from annihilation position to detector, and this distance, let's say, is L2. So in this case L1 is not equal to L2, but the speed of gamma photons in the body is the same. So it simply means that they will be detected by detector at different times, or simply we can say there will be time difference, and that time difference can be used, mean computer use that time difference that will be in nanoseconds to locate annihilation process, where annihilation is taking place, location of annihilation. So we can locate where annihilation is taking place in the body, or simply we can say we can use time difference, means computer use this time difference to locate the position of tumor or any part in the body of the patient where annihilation is taking place. And the second, this time difference also can be used to form image. So we can say to form image of tracer concentration in tissue, tracer concentration in body, or we can simply say in tissue, in tissues. If higher concentration, it means more gamma photons will be detected. So that's all what we need to understand, how we can use gamma photons to produce an image. And time difference, this is in nanoseconds, so this is done by computer. So with the help of time difference, we can locate position of annihilation, and also we can form image of tracer concentration in body of patient, or simply we can say in tissue. The line between two detectors, let's say this is detector D1 and this is detector D2. The line between these two detectors, this line is called line of response, line of response, or simply we can say this is LOR. The line between two activated detectors, that line is called line of response. That's all what you need to understand to write down answer for this question. Now let me show you the answer. This is how you can write down your answer. This question has 3 marks. So the first point you can say 2 gamma photons arrive at detector at different times. As we have discussed, there is a time difference and detected outside body of the patient by detector. So here we have detectors. So this ring consists of detectors. This is one point you can write on. Gamma photons arrive at different times as we have discussed and used to determine location of production of gamma, means location of annihilation. Time difference is used, and this time difference is also used to form image of tracer concentration. So this is the third point. If you write down these 3 points, you will get 3 marks. This was a great question on PET. Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on astrophysics from March 2022, paper 4, variant 2. In this lesson, we will discuss how to state luminosity of a star. We will also understand what is flux intensity, radiant flux intensity. Then we will talk about Stephen-Boltzmann law. We will also discuss Wien's displacement law. And also, we will do some calculations based on these 2 main laws. For part A, we need to state what is meant by luminosity of a star. Luminosity of a star is the total energy of radiations emitted by any star per second. Simply, we can say this is the total power of radiations emitted by the star. And luminosity of a star, it is distance independent, means it does not depend on distance from star. This is how you can write down your answer. And this question has only 1 mark. If you have written this mark, you will get 1 mark. Let's move on to part B now. For part B, it is given to us that luminosity of the sun is this, and the distance between sun and our planet is given is equal to 1.51 times 10 to 11 meters. Question is asking us to calculate the radiant flux intensity of the sun at the earth and give a unit with your answer. And so it's very straightforward question. Radiant flux intensity is equal to luminosity divided by 4 pi d squared, and d is the distance from the star. Now simply we need to plug in values and we can find out our answer for flux intensity. In this case, luminosity is given, that is 3.83 times 10 to 26 divided by 4 pi d squared. This is the distance from the sun. Simply you can say from the star, distance is 1.5 times 10 to 11 squared. And if we solve this one, our final answer in this case will be 1340 watt per meter square. That's all what we have to do for part B. So simply we can write down here, this is the magnitude and the unit is per meter square, watt per meter square. This is the unit of radiant flux intensity. Radiant flux intensity, it depends on distance. If the distance from the star increase, then radiant flux intensity will decrease, and vice versa is also true. If the distance decrease, flux intensity will increase. If we talk about the marks, this question has only 1 mark, so that is B mark. If you have written this one, you will get B mark. And this question has 2 marks, so the first mark you will get if you have written this formula, and the final mark is the answer mark. If you have written the right answer with right unit, you will get the second mark. For part C, question is asking us to use data from B to calculate the mass that is converted into energy every second in the sun. But for luminosity of the sun is given, and the luminosity of the sun is 3.83 times 10 to 26 watts. It simply means that this is equal to 3.83 times 10 to 26 joules per second. Means sun is emitting this amount of energy per second. Now we need to find out the mass converted into energy. So we have to use E is equal to mc square. We have energy, we have to calculate mass. So simply we will say in this case mass is equal to E over c square. But the value of E is given to us, that is 3.83 times 10 to 26 joules per second divided divided by 3.00 times 10 to 8 square of this. If we solve this one, we will get our final answer 4.26 times 10 to 9 kgs. So this much mass is converted into energy per second in the sun. So this is what question was asking us to calculate. So our final answer is 4.26 times 10 to 9 kgs kilogram. Our final answer has 3 SF because this quantity has 3 SF. So that's the reason our final answer is up to 3 SF. So you have to use 3 SF in this case. And this question has only 1 mark. If you got the right answer, you will get this mark. For part B, the radius of the sun is given. That is equal to 6.96 times 10 to 8 meters. We need to show that temperature of the surface of the sun is equal to this. So this question is quite straightforward one because luminosity of the sun is already given. So we can use simply Stephen-Boltzmann law, and according to Stephen-Boltzmann law, luminosity is equal to 4 pi r square times sigma times T to the power of 4, and this is temperature in Kelvin. If we use SI units, our final answer will be in Kelvin. Now we need to calculate temperature from here. So we can write down temperature T. So simply we can write down temperature T in this case will be equal to luminosity over 4 pi r square times sigma to the power of 1 by 4, and now we can just plug in values. Luminosity was given, that was 3.83 times 10 to 26 watts. We have to divide by 4 pi times r square. Radius is given, that is 6.96 times 10 to 8 square, and sigma is Boltzmann constant. Value of sigma is 5.67 times 10 to negative 8. So this is 10 to negative 8. Now if we solve this one, our final answer for T will be 5770 Kelvin. So temperature is equal to 5770 Kelvin. So this is what we need to show. And this question has only 1 mark. If we got right answer, we will get 1 mark. So this is our answer mark. For part E, it is given to us the lambda max of light for which the maximum rate of emission occurs, means the peak of this curve, the peak. So this is the lambda max. Not means the maximum value of lambda. In fact, this is the lambda at which the maximum rate occurs. So that is called lambda max, not the maximum value of lambda. Means the value of lambda at which maximum rate of emission occurs. That is called lambda max. Lambda max for the sun is given. This is equal to this. And temperature of the surface of the star Sirius is given. That is equal to 9940 Kelvin. But temperature of the surface of the sun we have already calculated in part D. That was equal to 5770 Kelvin. We need to find out lambda max for the star. For Sirius, means for this star we need to find out. We will use Wien's displacement law in this case. According to Wien's displacement law, lambda max T, this is equal to 2.898 times 10 to negative 3 meter Kelvin, not millikelvin. So lambda unit is meter. This is temperature. Temperature unit is Kelvin. So this is meter Kelvin, not millikelvin. Now simply we have to use this. So in this case we can say lambda max T. This is for Sirius. This is equal to constant, and if we use the same for the sun, that also will be equal to lambda max times T. It simply means that product of lambda max T is constant. So we can say for the star we can use 1. So I will use 1 here. For the sun I will use S. So this is TS. Or simply I can say this is sun, this is sun. I'm using 1 here for the star. We have to find out lambda max 1. So this is lambda max 1. This is for Sirius. So this is for the star. So we can rearrange. We can say this is lambda max of sun times surface temperature of sun, and we can divide by surface temperature of the star. So I will write down star here, surface temperature of the star. Lambda max for the sun we have, that is equal to 5.00 times 10 to negative 7 meter, and surface temperature of the sun is 5770 Kelvin. We can divide by surface temperature of the star, that is 9940, and we can find our final answer. Our final answer in this case will be 2.90 times 10 to negative 7 meter, and this is our final answer up to 3 SF. This is final answer. Simply you need to understand how to use Wien's displacement law. The product of lambda max and temperature, not time, and temperature is always equal to this one. So that's the reason we have said lambda max times temperature for the star is equal to lambda max times temperature of the sun, surface temperature of the sun. These two, they are equal, and then we can find out lambda max for Sirius. So very straightforward question. If you follow these steps, you will get 2 marks. In this case, 1 mark will be for this law. If you have used this law, this will be C mark, and the final mark will be answer mark if you have got the right answer.